Okay. Bye-bye. I think we can start, Marty. Marty, you think we can start?
Okay, pa-share na po nung slide. Magandang umaga po sa ating lahat. So, maraming salamat po sa pagsama sa amin this Saturday for another webinar that is part of our Research University component of the Filipino Science Hub. So, Kuya JP, if you can share the slide.
Doc Jeff, are you there?
Yeah. I'm just pulling it up.
Ayan, so marami po actually ang nagre-request nitong topic na ito, and for the longest time ay isa siya sa mga topics na marami kaming nare-receive na request since nag-start yung aming Research University na campaign. So for today, we will be having our basic statistical design of experiments, and this will be delivered by Professor Lara Ebal of the Institute of Statistics of UP Los Banos. Next slide, please. So before we start the webinar, let me remind our participants to please mute their devices and also turn their video off. Of course, unless you want to pose a question at the end of the webinar, you can press the raise your hand button, and you will be acknowledged by the moderator. And we also request you not to record this session because all of these sessions will be uploaded on our YouTube channel. Next slide, please. All right, so for the certificate of participation, we will be issuing one. After the webinar, we will post a Google form link to issue a certificate of participation for this session, and this will be posted in our Zoom chat box and YouTube live comments. And it will also be posted in the video description in YouTube in case you missed the live session. But certificates will be only issued to subscribers of our YouTube channel and Facebook page. Next slide, please. So I turn the floor to Kuya Jeff.
Okay. Okay, so magandang umaga po sa inyong lahat. Ako po si Jeffrey Bunkin, founder ng Filipino Science Hub. Isa po akong Filipino scientist who's based here in Houston, Texas. So at this point po, since marami po tayo usually mga bagong participants sa ating event na hindi naman po familiar pa sa Filipino Science Hub, so please let me introduce the platform. So Filipino Science Hub is an online platform that we founded back in 2012, and its main intention is to promote the cultures of STEM education and research among Filipinos. So at the moment po, this group is being led by a team of Filipino scientists and educators. Lahat po kami ay graduate of chemistry from the Institute of Chemistry at the UP Los Banos, and then we all sought higher education po in different areas of STEM. And so we are all volunteers dedicating our time to actually build a new culture, a new generation of scientists and Filipino science enthusiasts for the future. So what is it that we're trying to do? So the Filipino Science Hub intends to, again, to create a new or to improve the culture of STEM education and research in the Philippines. So kultura po ang ating inilulunsad. So and to us, what would make what would comprise a culture? So the first of which is kailangan we have to improve the mastery of STEM subject matter courses amongst Filipino students and teachers. So kailangan po mas naiintindihan ng maayos yung iba't ibang areas ng STEM. Pangalawa, you don't stop there. For you to be able to launch a culture, what the mind knows, the hands should actualize. So dito naman po yung actualization. So kailangan po na-apply natin ang ating mga natututunan. And so these two components are actually delivered by two of our main programs. So the first of which is Filipino Science Hub Education and Filipino Science Hub Research University. So ito po, in the succeeding slides, we'll talk about these more in greater detail. So we've been doing web events like this for the past 11 months or almost 12 months already. And so far po, we have carried out about 26 events so far. And these events are comprised of teaching webinars, career guidance talks, web lectures, research training courses like this one. So this is, I think, the 6th one that we are rolling out. And then about 5 STEM special topics. So far po, we have our events program has already rendered about 63 total training hours. So 63 hours po ng expertise na ibinahagi ng ating mga speakers. And then we have already educated about 14,000 live participants. And today po, we're anticipating like a fairly huge turnout because this is a very relevant topic to both the high school and college demographic. And so far po, we have rendered about 35,000 training hours. So maganda din po sa ginagawa namin ito, all of our contents are recorded. So kung meron man po mga parts dito na hindi niyo ma-cover or kung hindi man po ninyo masyadong maintindihan, pwede niyo po itong balik-balikan para po mas ma-improve yung inyong understanding ng mga topics na aming itinuturo sa inyo. And all of these events are uploaded on our YouTube account. Okay, so for today, I'm gonna hand the floor over to Marty Mateo because he's gonna talk about FilSciHub education.
Yeah, thank you, Kuya Jeff. So I'm back to introduce the education cluster of the Filipino Science Hub. So our main vision is to produce around or to impact around 27 million students in the future. This is by targeting academic frontliners, which is the main target of Filipino Science Hub, or yung followers po namin mostly are academic frontliners and they are in their early career. So if we project around 30 students per educator for their whole career of around 30 years, we project to impact around 27 million students. That can be STEM practitioners and nation builders in the future. Next slide, please. So we have also launched teaching webinars. This is in the onset of the pandemic. So during those early days of the pandemic, we launched learning through distance learning or online learning. So all of these resources are uploaded in our YouTube channel. So if you are a fairly new teacher on the field and you want to improve your skills on online teaching, you can always visit our webinars in our YouTube channel. Next slide, please. We also launched our modules. So we have biology, chemistry, and physics modules curated by BS Math and Science teaching graduates and students from UPLB. So ito po yung mga module warriors namin na sobrang masisipag, si IMG, si Ivy, and si Mark. Those teaching guides can aid, those modules can aid teachers and students alike. So it consists of teaching guides, class activities, and problem sets. And these are all accessible through our Facebook page and our website. That's www.FilSciHub.com. So curated po siya per subject. Madali nyo pong makita dun sa aming website. Next slide, please. All right, so we will be launching a STEM teaching fellowship where Filipino STEM educators get trained by Pinoy scientists. So this is a fairly new campaign of the Filipino Science Hub to bring in more teachers to our team and to be trained by mentors from the STEM that are STEM practitioners. So what are the perks of being a FilSciHub Ed Fellow? You will have a formal FilSciHub Ed membership and mentorship in practical science teaching. So this is more of experiential science teaching. And you can also present your STEM teaching materials on an online STEM education platform. And we will be helping you to improve your delivery of the subject matter, especially on the part of the content and the quality of your teaching materials. And details on how to apply to FilSciHub Ed Fellowship program will be released on April 20, 2021. And Kuya Jeff will add something. Yes?
Okay, so ito po, gusto ko lang dagdagan na detalye yon, and siguro po baka hindi namin, we might delay the launch of this mainly because there's a couple of very important aspects to this. So we are collaborating with a major for education foundation in the Philippines and a major teaching university po. Isa sa mga leading universities when it comes to teaching and pedagogy. And we're trying to come up with the mechanism po in such a way that you'll be trained in terms of basics of teaching STEM, and then courses po that we ourselves at Filipino Science Hub will come up with para po maturuan ng ating mga guro kung paano ba talaga yung practical and experiential way na pagtuturo ng STEM courses. So we're looking at about 5 to 10 core training courses. And then after po nun, lalagyan namin to ng practical. So meron pong quote-unquote internship ang ating mga guro where you will be asked to synthesize something out of the training materials that we provide you with. And then at the end of this, there's a possibility po that we might be able to provide you with CPD units, which I think is very relevant these days. And all these, we are actually going to be offering for free. Yung design po nitong mga courses na to at ng internship na to will actually, you can do it at your own pace. So kung medyo mabagal po, if it takes you 10 months to finish this, that's okay. If you can actually finish it quite quickly, then you can also do that. And what's most important is that you earn CPD units, and all of these will be for free. And then you will be presenting your work in front of an esteemed panel of educators and scientists. So ito po yung bago namin programa na ibibigay po sa inyo sa Filipino Science Hub Education Program. And kung gusto niyo po magkaroon ng idea kung paano ba yung mga parang training school po namin, JP will talk about it. We'll talk about such program that we actually carry out or that we conduct at Filipino Science Hub Research University. All right, JP.
All right. Thank you, Doc Jeff. Good morning, everyone. My name is JP Onya, and I am the head of the FilSciHub Research University. So as Doc Jeffrey mentioned, FilSciHub Research University is one of our core campaigns here at FilSciHub. And in this program, we are focusing on scientific research and its different aspects. So tinitrain po natin dito both the teachers and students, the entire range of research endeavor. Okay, so here at FilSciHub Research University, we will share some of the best practices in terms of conducting a research project, and we will share our own research experiences in doing so, and also some tips and advices. Okay, so FilSciHub Research University is composed of 8 mandatory courses. In fact, Our webinar today is one of the mandatory course for Research University, which is Statistical Design, our fifth. So we have already completed four mandatory courses from research ideation, literature review, experimental design, and research proposal. So tuloy-tuloy lang po ito until we could complete the entire course, and we will commence with the conference and poster presentation webinar. Okay, next slide. So, pag nakumpleto nyo po yung mandatory courses na yun, we will issue a certificate of completion, and yung mechanics po nung pag-issue namin ng certificate of completion is summarized in our online event last January to launch the FilSciHub Research University. So kindly check it out. I will also post the link on the confirmation email, the email issuing your certificates of participation for this webinar. So kindly check it out. And we also devised a Google Classroom for this, and the link for that is also provided in that email. So maraming salamat po. And the FilSciHub platform is always present in all of our channels, mainly our website, www.filscihub.com, and we're also present on Facebook, YouTube, and even on TikTok. And there, in our main platform, which is our website, www.filscihub.com, it contains all of our webinars, tutorials, modules, virtual lab, and features. So mamaya po, magkakaroon po kami ng official launch of a partnership with the Ateneo. And ayun po, isa po tong major partnership, and there we will share like a virtual lab or a virtual, mamaya na lang po.
Yeah. Ano po kayo, stay on, please stay on. Kasi yung sinasabi po ni JP, we collaborated with Ateneo Chemistry Society po. And what we did was we compiled a collection of STEM modules po in biology, chemistry, and physics. So yun po, these are on in PDF format. So pagpunta niyo po dun pag pinakita namin sa inyo mamaya on how to access those things, it's fairly straightforward for our teachers and students to access them and download them. So watch out for that po.
Okay.
All right.
Ayan,
so,
I think on that cue, Marty, you can take it.
Okay, thank you Kuya JP and Kuya Jeff. So before we introduce our speaker to you, let me acknowledge our viewers. So meron na po tayong around 400 viewers sa YouTube and 100 here sa Zoom. So around 500 participants already, and still growing. To introduce you our speaker for today, I give the floor to Dr. Dindiyu.
Thank you. Good morning sa lahat. It's my honor to introduce our speaker for this morning, Professor Lara Ebal. She is currently an assistant professor at the Institute of Statistics at UP Los Banos. And she is also, she got her bachelor's degree in statistics from Mindanao State University in Iligan City. And she got her Master of Science in Statistics at UPLB. And I believe she's currently finishing up her PhD in Stat in the same university with a focus on cognitive business management. She is an active member of Instat Statistical Consulting Group, Philippine Statistical Association, and International Statistical Institute. So let's all welcome Professor Lara Ebal. Ma'am, take it away.
Good morning po. Good morning po, everyone. Thank you for having me here as a resource person of this webinar lecture series. It's my honor, really, to be part of this lecture series. And will I share now my screen?
Yes, ma'am, please.
Okay. So, yun. Yes. Screen. Okay, so before I formally start, may I know if you can hear me?
Yes, ma'am.
clearly?
Clearly.
Okay. Can you see me?
Yes.
Can you see my slides?
Yep.
Yeah, okay, thank you. So thank you for letting me know. So before I formally start this lecture, okay, so I would like to thank the organizers of this webinar lecture for having me as a resource person. And then I would like to thank Instat for allowing me to share my knowledge on this experimental design. And I would like to thank everyone for giving time, okay, to attend to this webinar on basic statistical design of experiments. So now, before again to formally start, let me ask you this question. What comes to your mind when you hear the phrase experimental design? So you may participate. Okay, you may go to menti.com and enter this code. Okay, so I'll stop share first. Can you see the code? 96292853. Okay, so 96292853. Okay, so I will just wait. I will screen share my Menti. Okay. Okay. So 96292853. Okay. So I will wait. At least now I need to know the level of your knowledge on this experimental design so that I'll be able to discuss now in a way that you want it to be. Okay, so research, statistics, data, process, drawing, okay, flow. Okay, thank you for participating. So I see many responses here. So control group, IV, DV. So IV is independent variable, DV is dependent variable. Statistics, okay, common, data, statistics, research, setups, trials, methods, randomized, placebo group, layout, trials, grouping, randomization, lots of math. Grabe naman, lots of math. Variance, that's very important. Framework, okay, again, that's actually the layout. Okay, marami. May nagsasabi ng CRD. Yeah, I sense that some of you here have a good background, I think, in research or experimental design or in statistics. Some are just starting to learn, no, statistics or experimental design. Or some are just starting doing research, I think. Okay? And meron pa, thinking. So talagang nag-iisip pa kung ano yon. Okay? So thank you for letting me know. So far, we have 75, 76 participants in this activity. Okay, thank you for your time, no? Effort, mag-menti.com, pero thank you very much at least. I have the idea. So my ANOVA, yes, that's very common. RCBD, yeah, I see RCBD, CRD. Okay. Variable process, difficult. Oh, that's sad. Okay, but it's okay. I will try to simplify things so that you'll be able to appreciate experimental design. Hypothesis, yeah, I see hypothesis. Pattern, yeah. Quantitative, yes, that's true, quantitative. So we're dealing with data na quantitative. Experiment, treatments. Okay, so yung statistics and research at saka data, ANOVA, yung pinaka-common na in a way, that comes to your mind when you think of experimental design. Okay, so we've reached 102 participants. So lahat nag-participate, hopefully, no? Pero although you have 3 chances there, to answer this. So, yon. Okay, so will I stop here now? So I think this is a good, at least this gives me an idea of your level of knowledge in experimental design. So I'll stop sharing now. Thank you for your participation. Meron pa nag-ano eh. May humihirit pa eh. Sige, it's okay. So, okay. So maybe I'll wait, Sir JP.
I think it's okay. But
It's
I will
okay
just mention to everyone kung meron po kayong questions, you can post them in the chat box here in Zoom and also on YouTube. And then we will collect them at, para po sa discussion later. So at any point po during the lecture, you're free to post any question or comment and we will gather them. Ayun po.
Okay. Thank you, Sir JP. So I'll stop here na lang. And then you can just ask Sir JP or in the chat box.
Yes.
Okay,
Yes.
okay, I'll stop now. And then I'll go back to my slides. Okay, so at least now I know your level of knowledge in experimental design. So I have this outline here so that you'll be able to at least know the flow of my discussion. So number one, I'll start with the basic concepts. So basic concepts include this basic terms that we need to learn, okay? And then we also have these principles. And then we also have this basic design structures that we need to learn. So these actually include the CRD, the RCBD, and the LSD. So these are just basic design structures, but they are very important in our experiment or research. Okay, so we'll have a break also after, before we discuss CRD here in the next topic. Before we discuss CRD, we'll have a break. And then after we discuss the RCBD, we'll have a break. Okay, so we have 2 breaks. So don't worry. So just imagine that this will take like more than an hour. Okay, I hope, no? Kaya pa, no? So we'll see. Okay, so I'll start now. So I'll start with this basic definition on research, or specifically scientific research. So scientific research is a study conducted in contribution to science by the systematic collection, interpretation, and evaluation of data. So we need to have the systematic collection. Why? Because we need to come up with a valid data for us to have a valid interpretation and valid analysis. Okay, so that's why we must systematically plan, okay, before the conduct of the experiment or the research. Okay, so you are asked actually by your advisor or your teacher or your science teacher that you have to consult not to a statistician. Okay, I hope you agree with me, right? So do you hear that some other teachers or other advisors tell you the student to, okay, talk to your statistician or discuss this with your statistician? So then the question is really, what are the roles of statistics in a scientific research? So we have these roles. So number one, we have designing. We have designing experiments and surveys, and then collecting data or summarizing the data, and then describe data, estimate the parameters, and then test the hypothesis. So very basic on designing of experiments before the collection of the data. Because again, we need to have a valid data. So to come up with a valid data, we need to plan properly our experiment, or we have this designing of experiments. Okay, so before we discuss further this designing experiment, we need to understand some terms. So the common terms that we usually encounter in doing research, okay, is we have this treatment or treatments, experimental unit or sampling unit, and then the response variable. So maybe some of you are already familiar with these terms, but maybe those who are just starting their research or learning statistics, so we need these terms. Now we need to understand these terms. Okay, wait, it's not moving. Okay, so just to give you a picture of the relationship of those terms, okay, so we have this treatment. So how is this treatment related to experimental unit? So you can see the picture there. So you can see that the treatment is applied to the experimental unit, okay, and then later on we gather the data. So that's your response or responses. Okay, so this is how we picture out. And then, okay, so to formally define a treatment, okay, so treatment or factor, sometimes we call it a factor, includes the different procedures or conditions to be compared. Okay, so you have the intention to compare those procedures or conditions, okay, or formulations or applications or methods. Okay, and these procedures or conditions are actually your treatment levels. Okay, so these are the preset quantities of a quantitative treatment or categories of a treatment under study. Okay, so example, okay, so just to give you an idea, so we have this type of sugar. So you have the intention, or you really want to compare this different types of sugar in terms of sweetness, you know, when they are applied to cakes. Okay, so these types of sugar, which includes the icing, the granulated, and the dark muscovado. So these are the types that you want to compare. So these are your treatment levels. Another example is the type of irrigation. So this is a very agricultural example. You want to compare the different types, the surface, the sprinkler, the drip, and the subsurface. Okay, so how do you compare, or how do you compare this type? So you need to apply this to, for example, rice. Okay, and then later on we get the yield. Okay, so we can now compare in terms of yield. Okay, another example is the teaching method. So this is very common, I think, nowadays. Okay, you want to compare the performance of your students, no? Say math score. So you compare the teaching method online, face-to-face, and mixed online in terms of their performance. Okay, so just to give you an idea kung ano yung mga levels na yon. So depende yon sa research. So these are just my examples. Another term that we need to learn is this experimental unit. So the EU. So unit or group of units to which treatment is applied once. Okay, so you applied, you know the treatment, okay, you know your treatment level, you apply it to a subject or to a unit. So we call that experimental unit. So once ka lang mag-a-apply ng treatment sa isang experimental unit. And then, example, we have plot of land, a class of students, or a plant, or a tree, or a dish, no, or a flask, okay, in the laboratory, or a test tube, okay. And then another term is the sampling unit. So it's a portion of the experimental unit on which the response variable is observed and measured. So meaning to say, it's just a portion. So you cannot afford to measure the whole experimental unit or the whole plot. So you just need to get some subsamples, okay? Okay, so we call them sampling units. So example, a seedling in a seed bed, a tree in a group of trees, a sample in a batch. Okay, take note here. Wait, I will move this. Sampling unit may be the whole experimental unit. Sometimes our research is up to the level of experimental unit. So we don't do subsamples or we don't get subsamples. Okay, so that's it. So sometimes nga, same lang yung experimental unit with that sampling unit. Okay, another term is the response variable. Okay, so basically these are just the outcomes that you observe, no, in the field or in the laboratory. So example, yield of the crop, height of the plant, gain in weight, volume of sales, or math score, or any other variables or any other data. Okay, okay. So we have this simple example here just to test, know how you understand these terms. Okay, so determine the treatment, the response variable, the experimental unit, and the sampling unit. Okay. Number one, an experiment was conducted on the effects of 3 sulfur applications. So we have 3 levels, 300, 600, 1,200, on treating scab disease in potatoes. So each application were randomly assigned to 5 plots. So if you can imagine, we have one application applied to how many plots? 5, okay? And this percentage of surface area of potato that was infected with scab, or we call it scab index, was measured from each plot. Okay, so based on this example, can you determine now the treatment? What's the treatment of the study? Sulfur applications, and then response variable. So what's your data here? Okay, your scab index, and the next is the experimental unit. So where do you apply? Where did you apply the applications? The sulfur applications. So to the 5 plots or to the plots. So that's your experimental unit now. Okay. How about sampling unit? Do you have a sampling unit here? Okay. So let's see. Okay, we have no sampling unit in that experiment or example. So just to summarize, again, the treatment in the example is the sulfur application, and then the treatment levels. So we have these specific levels, 300, 600, and 1,200. And then the response variable is your SCAV index or the percentage. And then the experimental error is where you applied your treatment, so yung plots. And then sampling unit is or none, or there's no sampling unit. Okay, another example. A researcher wanted to determine if there were differences on the amount of calories among the 3 types of hot dogs. So, for example, we have these 3 flavors, beef, pork, and chicken. So he selected 3 hot dog packages from each type and took 3 pieces of hot dogs from each package, in which he took measurements of the amount of calories. So, ang haba, ano? So, what happens now is that we have these different types, and then we have, from each type, we have different packages. However, we're not able to measure. We cannot measure all the packages. Okay, so what we do is we get only few, or say 3 hot dogs. Okay, so now determine the treatment, the response variable, the experimental unit, and the sampling unit. Is there sampling unit here? Okay, so I'll read again the problem. Okay, so I'll show you now the answer. Okay, so you can see the problem here in the left-hand side. Okay, so the answer, okay, we have treatment, the types of hot dogs, and then the treatment levels, we have the specific flavors, or pork, chicken, beef, and then the response variable is the amount of calories, and then the experimental unit, okay, that's the packages, the hot dog packages. Okay, and then now here comes the sampling unit, which are just the 3 pieces of hot dogs from each package. Okay, so you can now relate now, there's an experiment that up to the level of experimental unit, then there is also another experiment which is up to the level of a sampling unit. Okay, so another term that we need to learn is experimental error. So this is the variation in the observed values of the response variable from the experimental units treated alike. So if you can imagine, there is this treatment level or condition or procedure applied to an experimental unit. Okay, but take note, you do not only apply once, okay, the treatment level to only one experimental unit. You have to consider more experimental units. Okay, and then you also expect that these experimental units must be have the same responses or outcomes, or at least they are close to each other, right? Okay, so now if they are different, or there is this discrepancies or differences among these experiment or responses from these experimental units, then that's incorporated in the experimental error. Okay, so we need to have a measure of experimental error. That's why we need to come up with many experimental units or replicates. Okay, okay. Why? Even if we try to control, and even if we try to only apply one kind of treatment level in several experimental units, okay, they still differ because of some reasons. Number one, inherent variability of the experimental materials, maybe because of the material used, no. Errors in experimentation. So it is usually the human error. Okay, it's the person who is measuring or gathering the data. Then errors in observations or in the measurements. Okay, so these are some sources of discrepancies, no? Then we also have this combined effects of all extraneous factors. So there are other factors that we need to know, or at least we need to have a good background of that certain kind of research. At least alam natin kung ibang factors that can contribute to that response. Okay, so we need to also try to control them. Okay, because they actually, yun nga, the source of experimental error. Okay, so just to illustrate, okay, so I think you're already familiar with this picture or diagram. Okay, so the experimental comes here. Okay, so these values here, the discrepancies between Y11, the Y12, and the Y13. Okay, so the discrepancies again are incorporated in the experimental error. Now, another example. Okay, so under experimental errors, I'll just show you. An experiment was conducted. It's the same example, the potato example that I gave you. Okay, the experimental error there consists of the pooled variation, okay, the pooled discrepancies now, among the 5 plots. So what are these 5 plots? Yun yung experimental units natin. In the same sulfur application. So in the same level of sulfur, say 300 or 600 or 1,200. So at least now we learned that we have this experimental error defined in this way. So it's the pooled variation. Okay, another term that we need to learn is sampling error. So if we have experimental unit, we have this experimental error. Then if we recall, we have the sampling unit, so we also have the sampling error. Okay, so sampling error is a measure of variation among sampling units within an experimental unit. So if you can imagine, yun nga, we conduct subsampling, or we use subsamples, okay, when sometimes we cannot measure the whole plot or the whole experimental unit. So sometimes we get 3 or more. Okay, so those variation of the responses of the sampling units, okay, are incorporated naman in the sampling error. Okay, so that's it. So we have experimental error, we also have sampling error. Now we have an example here just to give you an idea. Okay, so recall we have this hot dog example. We have 3 types of hot dogs, and then we get 3 packages from each flavor, and then from each package we get how many? 3 hot dogs. Okay, so now the variation of these 3 hot dogs, the differences in terms of calories, okay, are incorporated now in the sampling error. So sampling error consists of the pooled variation among the 3 hot dogs taken from the same package. Okay, that's it. Now another term is precision. So I think you're all familiar with this, but we'll just have a quick review on this now. It's the ability of a measurement to be consistently reproduced. Okay, as you can imagine, again, we apply the treatment to the experimental units, to several experimental units, and then these measures coming from this, or measurements coming from these experimental units must be close to each other. So that would mean na we are getting precise estimate. Okay, so again, precision is measured by variance. So we have to compute for the variance in order for us to know if we have a high precision or low precision. So ways to increase precision. 1, to increase the number of samples. This is very common way. Okay, it means that you can increase your experimental units, or you can increase your replicates. Another is skillful grouping of experimental materials. So the researcher should have a way, should have this skill, in grouping the experimental materials. Dapat alam niya na homogeneous ito or magkakaparehas ito. So, yun. Then proper selection of treatments. So you should have a good background of your research, okay, to really know ano yung gusto mo i-compare, anong treatment, okay, na i-consider mo. That will also increase the precision. And then aside from precision, you have accuracy. So it's the closeness of the observed values to the true value. Okay. So if precision is the closeness of this measured values, accuracy naman is the closeness of that value to the true value. So sometimes this true value is the true mean. Okay. So this is measured by bias. Okay. And then ways to increase accuracy. Okay, we refine the experimental technique, and we have to properly select the treatments. Okay. Now, another term is the layout. This refers to the final arrangement of the treatments, okay, over the whole experimental area. So, as you can see in the right-hand side, we have this example, okay, of this arrangement of treatments. So, for example, B1 or the block 1, we arrange the treatments as A, B, C, D, and then for the next block, we have this arrangement D, A, B, C, and then the third block C, D, A, B, and then the fourth block B, C, D, A. So this is an example of a layout. Okay, so another term, maybe this is new to you, or I don't know. We should understand this too, because this is very helpful in your experiment. So fixed effects, all factors under the test are fixed factors. So ano yun? So a factor is considered fixed when its levels are selected on purpose. So you really have the intention to compare these factors. Example, you have T1, T2, T3. Gusto ko lang na sila lang yung i-compare. And then The interest is on the effects of this selected level of fixed factor. No inferences shall be directed at any treatment level that is not included in the experiment. Okay, this means that when you have your conclusion will only be applied to the other, will only be applicable to other experiment or research using the same set of levels. So T1, T2, and T3. So that's under fixed effects. Now for random effects, syempre kung may fixed, may random. So all factors under test are random factors. A factor is considered random when the levels of the factors tested are a random sample from the population of levels. So example, as you can see here in the picture, you have many levels. So we have T1, T2, T3, T4, T5, and T6. Then we just randomly select. Okay, wala kang intention na may specific treatment level na gusto mo i-compare. You just randomly select T4, T3, and T6. So it's fine. Okay, so what you are doing is actually under random effects. So interest is on the population of treatment levels from which the random sample of treatment levels was drawn. Okay, as you can see in the picture. Then population of treatments will then be described in terms of the sampled treatments. Okay, so just to give you an idea of this too, we have this example. A drug study used 0 mg, 5 mg, and 10 mg of an experimental drug. Okay, so take note, may 0, may 5, may 10. So under fixed effects, the conclusion is applicable to other studies or treatments that use the same values of drug. Okay? So applicable lang yung conclusion mo na nagamit ng 0, 5, and 10. Okay, so dun sa other studies which also use this 0, 5, and 10. Okay, if you have that intention to compare 0, 5, and 10. Now, for random effects, the conclusion is applicable to other studies that use other values beyond these particular values. So, these 0, 5, and 10 were just randomly selected. Okay? And then, yun. So, whatever the conclusion from that study, okay, will also be applicable to other studies, not even other studies which actually do not use this 0, 5, and 10. So, pwede yun kasi randomly selected lang din naman yung 0, 5, and 10. Okay, so these are the terms that you learned, I hope, no? So, treatment, experimental units, sampling units, response variable, experimental error, sampling error, precision, accuracy, fixed effects, and random effects. Okay, so we'll have a, okay, next set, okay, of topic. So we go back to this. In statistics, so I hope you understand those, you have understood to those terms, okay? Now we go back to this. In statistics, a procedure of a randomized experiment is governed by the experimental design. So bumabalik tayo dun sa experimental design. But, okay, we have this term, randomized experiment. Okay, what is this? Yung ibang alam lang ay experiment, but actually it's a randomized experiment. Okay, let's see what is a randomized experiment. So take note first, if we have experiment, it is characterized by the following. Number 1, presence of treatments. Okay, you know already what is treatment. Experimental units, okay? And by the way, the treatments are assigned to the units, okay? And by the responses that are measured. So you have these terms already, no? You are all familiar with this. The next is the randomized experiment. So it's an experiment where assignment of units to treatment groups are randomized. So there is this randomization occurring in this kind of experiment. So goal is to see the effect of the treatment while controlling for other factors. So you should have a good background again of your experiment so that you can control them, those other factors that can affect your outcome or response, so that you can focus on the comparison of the effects of the treatments that you really want to compare. Okay? I hope you get me, no? So you have to control so that you can focus again to other treatment levels that you want to compare. Now, present the strongest support to causation. So this randomized experiment presents strongest support. This means to say that this randomized experiment ensures us that the treatment is really have an effect on the outcome or the response. Okay? That's why we have to conduct this randomized experiment if our intention is really to compare. Okay. So we have these advantages of randomized experiment. Number one, it allows the setup of direct comparison between treatment of interest. So direct comparison. Okay. Next, minimize any bias. So na-minimize natin yung bias. Why? Because we conduct randomization. Next is we minimize the error. Actually, this is because of the experimental error or the replicates. Now you try to have more replicates or experimental error. Experimental unit, okay, to minimize the error. And then another is that the researchers are in control of the experiment. Again, you should have a good background para ma-control mo yung other factors that can influence the outcome. Okay, so randomized experiment must be performed using appropriate principles and design and techniques of experimentation. So we need to have these principles. We need to know these principles, okay, so that we are confident with our experiment, okay? And we need also to know those design structures so that we are confident with our experiment to come up with a valid conclusion. So what are those principles? Number one, replication. Number two, randomization. Number three, local control. So we start with this replication. So it's needed for the validity of the experiment. Okay. Is the repetition of the application of treatments on a number of experimental units. Okay, so repetition of the application of a certain level of treatment. Okay, again, recall again that we try to apply a certain condition or certain treatment level to several experimental units, okay? And then we expect that these experimental units must result to almost the same measurements or values, okay? So that this actually ensures us that we are getting the correct result or results, okay? That's why making this experiment valid. Okay, now, functions of replications to provide an estimate of the experimental error. So are you already familiar with this experimental error? And replication also helps the increase of precision of the estimates. And then increase the scope of the experiment. So if you consider many experimental units, and these experimental units have these inherent characteristics, okay, or conditions, and then if we use them, so we are also trying to, widen our scope. Kasi iba-ibang conditions sila galing, right? Okay, so that's the advantage now of replication. Another principle that we have to learn is randomization. Aside from providing the estimate, okay, of this experimental error, we also need to have this estimate to be valid. So if we have a valid experiment, we also have to have a valid estimates. So this can be done through randomization. So it's a process that ensures treatments will have an equal chance of being assigned to an experimental unit. Okay, so we randomize. And then local control. So is any technique used to minimize experimental error? So although you want to measure experimental error, but you want to minimize that. Okay, we want to minimize the experimental error so that we can focus only on the differences or the discrepancies among the treatment levels or among groups. Okay, makes the design efficient by making the test more sensitive and powerful. Powerful in a sense that we're able to compare or to detect any differences if that differences really exist. Okay, so common techniques of local control. Number one, use of most appropriate statistical design. So you have to know those design structures. Use of proper shape and size, okay? Then use of concomitant variables. So this will help you, okay? Although this is not necessary in your analysis, but this you can try to recognize them and control them. And then we have this grouping, blocking, or balancing. So these are common ways or techniques to have this local control or error control. So what are these grouping, blocking, and balancing? So grouping is placing the homogeneous experimental units into groups and comparing the treatments in each group. Okay, as you can imagine, we try to have these experimental units. We group these experimental units na of the same characteristics or of the same condition. Okay, so that's grouping. Then blocking, grouping experimental units into blocks such that the units within a block are relatively homogeneous. So we try to make sure that in a certain block, all the units or experimental units inside there are of the same condition or homogeneous. And then we also have this balancing, assignment of treatments to an experimental units to achieve balanced configuration. So as much as possible to increase the power of the test, we want our design or experiment to be balanced. Meaning, if we have this treatment 1 applied to 4 experimental units, then we also have this treatment 2 applied to this another 4 experimental units, so 4, 4. So that's balance, no? But sometimes in our experiment, it's very difficult to acquire, or it's expensive, no? Yung isang level, expensive siya, so we cannot afford to have this same number of experimental units. So pwede ko konti na lang experimental units for that expensive level. Okay. But it's still, no, you can still analyze kahit unbalanced. Now, to summarize, what are the principles that we need to know or we need to in the performance of experimental design or experiment? We have, what's that? Randomization, replication, and local control. Okay, so next is we have the steps in conducting an experiment. So I'm not sure if you're already familiar, since if you're doing experiment, familiar na kayo. If you're starting, so at least this is your guide. So state the problem of the study, formulate the hypothesis, define the data that you want to collect, or define the responses that you want, no? And then devise the experimental design, and then conduct the experiment. So again, before the conduct of the experiment, you really have to consult your statistician. Oh, what could be the appropriate design if my objective is this, if my research hypothesis is like this. Okay, so before the conduct, so hindi yung the other way around na may data ka na tsaka ka nag-consult. Okay, so next, okay, again, experimental design concerns with planning experiments in order to obtain maximum amount of information from available resources. Okay, so we need to have a good plan, no, of our experiments to maximize, no, your response. And then involves the assignment of treatments to the experimental units. So I think you already know that we have to randomize, no? We have this randomization of treatments. Now, so just to give you a picture of this experimental design, so take note that this experimental design has 2 structures. First is the design structure. The second is the treatment structure. Okay, so yun. So design structure is actually yun yung mga CRD, RCBD, LSD. So that involves randomization and grouping. While this treatment structure involves the factors, so the number of factors or the combination of factors that we want to compare. Okay, so treatment structure consists of the set of treatments, treatment combinations, or populations that the researcher has selected to study and or compare. So these are possible treatment structures, as you can see in the right-hand side. One-way treatment structure, factorial arrangement with 1 or more controls, nested treatment structure, or fractional factorial. So we will just focus on this one-way treatment structure, but this is very important, okay? And then if you already understand this one-way treatment structure, you can proceed. You can continue learning this other treatment structure, the factorial or the fractional factorial or the nested. Okay, now another component again, okay, aside from this treatment structure is the design structure. So the design structure refers to the grouping of the experimental units into homogeneous group or blocks. So this is where you, okay, as you can see, this is where you can see this structures like CRD, RCBD, and LSD. There are also other structures like split plot, strip plot, and strip plot. You take note that this split plot can be combined with CRD or RCBD, or strip plot with RCBD. But we will just focus on these first 3 because these are the basic design structures, which can also be applied later when you have this more complicated design structure like split plot, like those. Okay, so try this. Okay. So we have the same example, the potato example I gave you. Wait, Okay, this one. Okay, so you are asked here, what is the treatment structure? Okay, since we are dealing with one factor which has these 3 levels, then we have one way as our treatment structure. Okay, now what is the design structure? Although you have not learned yet this design structure CRD, but this is actually the randomization of different levels, no, to the different experimental units. So as you can see, nag-randomize lang siya ng treatment applications dun sa experimental units. That's why the design structure here is the CRD. Okay, but we will learn more on CRD later. Okay, and then another example is this, again, the potato example, pero hindi lang sulfur application yung concern natin. We also have this other factor, the sprinkler irrigation use, so which can have this center pivot, wheel line, and solid set. So we have these 2 factors, and then we combine these 2 factors. So that is actually factorial na. So the treatment structure is factorial, but then the design structure is still CRD. Okay, since these different combinations of different factors are randomly assigned to the different plots. Okay, so maybe can we have a break, or
Yeah,
you want?
I think we will have a 5-minute break at
Okay,
this point. And
Okay.
Marty?
Yeah, so we
I
will
will stop
have...
share.
Okay, okay po ma'am. We
Okay.
will have a break. So, medyo marami po tayong terms na nakuha kay ma'am for today. So, ang maganda naman po dito, if dahil medyo fast-paced po talaga yung ating discussion, pwede niyo po siyang balikan sa YouTube if ever may na-miss kayong parts. And marami na pong questions sa YouTube and sa Zoom chat box. So, mamaya po i-entertain namin yan. So, by parts po kasi yung gagawin namin dito sa discussion ni ma'am. So we'll give Ma'am Lara a mini break. So before while we are on a breaks, may i-discuss po ata si Sir Jeff.
Okay, so gaya po na sinabi namin kanina, we'll talk about our collaboration project with the Ateneo Chemistry Society. So this actually focuses on the creation of STEM teaching modules po, particularly in chemistry, biology, and physics. So, Marty, can you guys see my screen?
Yes, kuya.
Okay,
Yes,
so
yes.
i-demo ko lang po sa inyo kung paano po makikita yon. So for example po, punta kayo sa FilSciHub.com, and then what you do is you scroll down. And when you scroll down, go to the BAL click on the BAL button. So this is Build a Lab. This is our collaboration project between the Ateneo Chemistry Society and Filipino Science Hub. So what is BAL? So BAL is a year-long flagship program of the Ateneo Chemistry Society. So historically po, what they did was meron po silang at least dalawang high schools in Manila na ina-adapt nila. So they provide resources po for them to be able to perform laboratory experiments. So they provide equipment, they provide reagents for chemistry experiments. So taon-taon po nilang ginagawa yan. But then, since 2020, we got surprised by the pandemic. So binago po nila yung approach naman nila ngayon for their program. So specifically, what they did was, instead of delivering equipment, nag-create po sila ng grade 9 chemistry modules. And so what they did was they approached us to partner up with us, because since in addition to chemistry teaching modules, we have also been coming up with biology and physics teaching modules. So pinagsama po namin ito, and we combined all of the contents on the BAL webpage, which again you can find on our official website. So go to www.FilSciHub.com. So it has all the information about the BAL project. So basahin nyo na lang po yan. This is actually like a very good project that Ateneo Chemistry Society has been generous enough to put up for this year para po talaga matulungan ng ating mga guro at mag-aaral during the pandemic. And then, pag scroll down nyo pa po, makikita ninyo, meron po dyan specific entry for or hyperlink to our chemistry module. So what you just have to do is you have to click it, and then if you go to that page, makikita nyo po dito, it's Build a Lab Chemistry Modules tab, And dito po, nakalista na po lahat ng chemistry modules that we have uploaded. So the first of which is the worksheets na ginawa po ng Ateneo. Para po siyang book chapter. It covers a number of different, and I will click on it just so you can get an idea of what each content has. So this is the specific worksheet, grade 9 worksheet that Ateneo Chemistry Society had actually composed. So this is for grade 9 specifically. And then if you look at the topic, so it's covering several chemistry topics for high schools: electronic structure of matter, chemistry, chemical bonding, organic chemistry, mole concept, special discussions, chemical formula and nomenclature, dimensional analysis. And what's more important about this is that meron po silang worksheets. So meron po itong practice problems for students. So these are things that you can actually access through the BAL webpage. Okay, I'm going back to the page because to the chemistry modules for the BAL program. Papakita ko rin po sa inyo yung mga modules naman na ginawa namin. So if you click on these links, so it will direct you to our Google Drive page where you can directly download everything as PDF. So buo na po yung document na yun, mata-download ninyo. Ito naman po yung teaching modules na ginagawa namin for chemistry. So for example, for ideal gases, what we provide is the set of core standards, course objectives, and at the same time, like some of the most essential learning competencies that should be taught, for these lessons. So dyan po, nakadetalye po dyan lahat. So lahat po ito, kino-cross-check namin with the guidelines of DepEd. And then we begin with a review or a reconnect of some of the lessons related to each topic. We provide sample problem solvings, for the concept. So ito po, meron siyang discussion, meron siyang problem solving as well. And then at the end of all these, lagi po tayong merong problem set. So dito po, bibigyan din namin kayo ng tanong, and then in the same package, there are also some answer. There is an answer key that is provided. So again, ito po yung kompleto. Bukod sa meron kayong parang lecture part or teaching part, meron rin po ditong mga sets of questions and answers na pwede nyo gamitin para mapag-practicean ng inyong mga estudyante. So like I said, we have that for chemistry. We also have that for biology. So hindi lang po tayo nagfo-focus sa isang subject dito. So pagpunta niyo po sa biology modules namin, these are all teaching modules and problem sets that we created and curated specific to high school chemistry. So both junior and senior high topics. So i-browse nyo lang po yan if there are things that are relevant to you in your classes. So ito po, marami po talaga kayong makukuha ditong material. So these are complete teaching modules. And then lastly po, we also have our physics teaching modules. So ito po medyo dumadami na po yung contents namin dito. So far we have about 8 teaching modules on specific physics topics. So again, same content. It will have the course, the teaching guide. It will have the discussion part, so you can get some visual aids from these packages. And then lastly po, again, we have the problem sets. And then what's one very important thing that we would also like to mention is the fact that very recently, some of these modules po, we came up with audio-visual versions of these. So punta po kayo dun sa YouTube channel namin, hindi lang po siya set of infographic. There are some discussions. So meron pong video discussions guiding you through each module. So hindi lang po siya dapat basahin nyo. Pwede nyo na rin po panoorin at pakinggan ang mga teaching modules namin. So again, this is our BAL project in collaboration with the Ateneo Chemistry Society, and it's so our webpage is already live for more than a week now. So pwede nyo po yung bisitahin dyan every time na naghahanap kayo ng modules na posibleng na-cover ng topics namin. Okay, and if you have questions about the BAL modules, reach out to us through the comment on our websites, and also reach out to us through our Facebook page. Maraming salamat po.
Kuya Jeff. Thank you, Kuya Jeff, for that discussion. So, welcome. Ito po ay welcome addition sa lumalaking partnership ng FilSciHub. So, marami pa po kaming other partnerships to launch with many schools and many organizations. So watch out for our partnerships and launching of other new programs. So Ma'am Lara, are you ready to proceed?
Yes po, I'm ready. I will share na po my slides. My
Okay po.
next set of, wait, it's here. Okay,
Alright,
so
so
can you see the slides now?
yes
ma'am.
po, ma'am.
Can you see me?
Yes.
Can you hear me?
Yes, ma'am.
Loud
Okay,
and clear.
I'm good. So again, so we'll just continue with this discussion on experimental design. So far we learned about those terms, that's very important terms, no? So for us to at least yung confidence natin sa experiment, in doing the experiment, okay, is mataas. Okay, now the design structures that I was talking about, okay, that will be discussed for this webinar are only this CRD, RCBD, and the LSD. So we'll start with the CRD. So what is CRD? Okay, so if you can recall, mention ko na yung CRD na initials kanina. So this is just a completely randomized design. So this is the most basic experimental design. Okay, all experimental units are considered the same and no grouping among them exists. So there's no grouping. Okay, and then the treatments are allocated randomly to the whole set of experimental units, so that's the EUs, and each experimental unit has the same chance of receiving any of the treatments. So as you can imagine, ito lang po yun, ito yung picture na to. So we have this, for example, different plants, okay, and then we have this treatment levels, blue, orange, and green. So we apply the blue, okay, treatment, okay, or the blue fertilizer, for example, so to this plant. So na random lang. So we just randomly assign treatments. So, and then also for the orange, okay, fertilizer, okay, we can randomly apply this to the same, okay, experimental area. So we have this plant here receiving orange treatment, and then another plant receiving the orange treatment. And also for the green, okay, so this green plants actually receiving the green fertilizer. Okay, so just a picture of this CRD. Now, take note that, okay, they are used when experimental units are homogeneous. Okay, meaning the same variety, the same age. Okay, so depende yun sa research or sa experiment. Okay, and there is an effective local control. Okay, so how to have this effective local control? Okay, so how to minimize experimental error so that we have this effective local control. So usually, this CRD is usually done inside a laboratory or greenhouse. Okay, kaya yun, effective local control kapag inside a laboratory. Because there is the same temperature or same setup like that. And then we have this requirement. So take note of this requirements, T treatment levels to compare. So take note, we have 3 or more levels that you want to compare. And then we have this N, experimental units must be homogeneous, again, homogeneous. And then N must be greater than or equal to the 2 times the number of treatment levels. So if you have 3 treatment levels, so 2 times 3, you have how many? At least 6. Okay, 6 experimental units. Okay, and then take note also, we have this Ri or replicates are assigned to each level of T. So for each level, there should be a value of R. So for level 1, you have R1. For level 2, you have R2, and so on. So now this replicates, okay, can have the same number. Okay, we have R1 equal to R2 or equal to RT. Okay, so we can now have a balanced design. Now for an unbalanced, so yun nga, we cannot sometimes afford to come up to have more replicates for a certain level kasi mahal siya. So we also have this unbalanced design or experiment. Now, since we are dealing with randomized experiment, so we need to have this randomization. So how do we generate or how do we conduct randomization? So first, okay, we have the steps. Assign the first R1 to T1, next R2 to T2, and the last R3 to T3. Okay. Now, second, obtain a sequence of random numbers. So you can use your calculator or Excel, okay? Or you don't need a software for this, no? Pwedeng mano-mano. Third step is to rank the random numbers. Okay. Okay, so as you can see here in the illustration, having T 3 levels, T1, T2, T3. And take note that T1, okay, is assigned to how many replicates? 2. So we have T1, T1 here. And then T2 is assigned to 3 replicates. So we have 3. Okay, that's why we have T2, T2, T2. And then for T3, we have 4 replicates. So we have 4 T3s. Okay, now we generate random number. Okay, so we have this. So it can be any numbers, no, from 0 to 1. And then this, next is we get the rank. Okay, the rank, okay, so the lowest generated random number, okay, this one here, has rank 1. And then the second to the last lowest, which is 0.218, has rank 2. Okay, so these are the ranks now. And then we can have the layout. Okay, so as you can see, T3 is assigned to this one here, and then T1, can you follow? For this 2, we have T1, and then for this 3, we have T3 again. Then 4, we have T2. Okay, so this is now your layout. Please stay back. And now next, is we expect to have this data presentation. So since we are dealing with 2 replicates under treatment 1, then we have 2 observations, okay, because we have 2 replicates. So from each replicate, there is 1 observation. Okay, so for treatment 2, ganun din. We expect to have, we use 3 replicates, then we expect to have 3 observations. So this is the data presentation. Then we also have this replicates, the number of replicates, and then the total, and then the mean. So basic data presentation lang po. And then, take note also that once we have the responses, we can model the responses. So we have this means model, and we also have this effects model. So for the means model, we have this yij equal to mu I plus epsilon ij. So this yij is your observed value, yung nakuha mong response. And then the mu I is the mean of the I treatment level. Okay, the mean for that group, for that treatment level. And then the epsilon ij is the random error. Okay, so we can also, okay, have this effects model, okay, for the responses. So instead of having just mu I plus epsilon, we have this mu plus tau I. So this mu plus tau I is just equal to mu I. So meron po dito sa side, sa upper right, meron tayong way, no, to come up with this, okay, to relate this model to the previous model. Okay, so in the previous model, mu I. So this mu I is just your mu plus tau I. And then tau I now is your mu I minus mu. This is used, okay, this model is used when you want to estimate for the treatment effect. So the tau I's. That's it. And then the mu ij, again, your response or the observed value. The mu is the overall mean. The tau I is the effect of the I treatment level. And then the epsilon is the random error. So that's it. Okay, these models are very important in stating for the mean and later on dun sa conclusion. Now, okay, so we will now have this example under CRD. Okay, so an experiment was conducted to determine the effect of levels. So we have 30, 60, and 90. So this is very common example actually. Ginagamit ito sa Instat. Of nitrogen on the yield of variety of corn. So 12 homogeneous plots. So imagine the plots. Okay, so 5 by 30. Were prepared and each level of nitrogen was randomly assigned to 4 plots. So, meron kang 3 levels, then you randomly assign these levels or applications to the different plots. Okay? Now, okay, recall lang po, ano po yung treatment natin dito? We have, treatment is the amount of nitrogen, that's 30, 60, and 90. So that's the level. In experimental units, yung plus na in-apply ng nitrogen. And then the response variable, the yield of corn. Okay, so this is now your data. So it's a balance. Now, we have this question. At alpha 0.05, are there significant differences in the mean yield? So we're talking about comparing the means. Mean yield among the different nitrogen levels considered. Okay, so how do we answer that? Okay, so we have to recall the steps, no? In order to answer that question. Okay, you have to take note, state the HO, the HA, decide for your alpha. wherein here we already stated that alpha is 0.05. So we set alpha equal to 0.05. Select the test statistic. So you have to know what is the appropriate test procedure so that you will be able to know what is the appropriate statistic and how do we compute that. Okay, and then collect the data. Okay, and make a decision, then write the conclusion. Okay, so start with the hypothesis. Okay, as I've said, meron tayong tinatawag na fixed effects, meron tayong random effects. So this will be reflected, no? Yung fixed and random effects will be reflected in the hypothesis testing. But you can actually always use this means model. Na we just use the mu. So for the null hypothesis using the mu's, we have mu1 equal to mu2 equal to mu t. So meaning, so in words, you say all the treatment level means are equal. So the same lang daw yung means now from different groups or from different levels. Versus the alternative that at least 2 treatment level means are different. So, or at least one is different from the rest. Okay, pwede yun. So this is somehow a friendly way in stating the null and the alternative hypothesis. But if you want to know what could be the null or the alternative hypothesis when we have the fixed effects model, then we can have this tau 1 equal to tau 2 hanggang tau t kung ilang levels equal to 0. And that would mean that there is no effect at all of all the treatment levels. So actually, they just have the same meaning, yung means model at saka fixed effects model, and then pati din yung sa random effects model, wherein you use this notation sigma squared tau equal to 0, wherein there is no variation. So pag no variation, equal lang, di ba? So there is no variation among treatment levels. Yeah, so I'm just showing this to you just to give you an idea na pwedeng you state the HO and the HA the other way around. Yung, aside from the means, you can use the fixed or the random effects. Okay, so go back to the example. We state now, okay, using the mu1, mu2, mu3, okay, we have your HO here. Or we say the mean yield of corn among the different nitrogen levels are the same. Versus the HA, at least mu1, mu I not equal to mu J, where I and J, okay, I or J equal to 1, 2, 3, okay? And then at least one of the nitrogen levels has a different mean. So yun yung ibig sabihin ng HA natin, yung symbol ng mu I not equal to mu J. At least one nitrogen level has a different mean. Okay, so the test procedure, I don't know if, okay, familiar naman siguro ng F-test, no? Okay, so one procedure is we can use the F-test using one-way ANOVA. Bakit? Kasi if we satisfy the assumptions, we can use the F-test. If we do not satisfy the assumptions, we cannot use the F-test. So we have maybe to transform the data or use non-parametric method. Okay? So yun. So not all the time that we use the F. But this time we will just focus on the F, and then also given that the assumptions are satisfied. Okay. The test statistic, since we are using the F, so we have this formula. This is the ratio of MSTR. So MSTR is the mean square of the treatment over the mean square error. Okay, so how do we get this value? So we need to construct an ANOVA table. Okay, then decision rule, we reject HO if the F computed is greater than the F tabulated. So always greater kapag nagre-reject. Okay, and then, okay, this now the right hand side is your, okay, the F tabulated. Okay, if you do the manual, okay, way of the analysis, we can have this F tabulated, okay, dun sa Excel, or we can use another way of deciding whether to reject the HO is, whether or not to reject the HO is to use the p-value. So hindi lang F, pwedeng p-value. So reject HO if the p-value is less than or equal to alpha, wherein we set alpha equal to 0.05 in our example here. Otherwise fail to reject the HO. So yun yung OFTR here. Okay, so again, as what I've said, this ANOVA is very helpful in computing for the F, which is the ratio of the MSTR over MSE. So what is really ANOVA? So ANOVA is a way of partitioning the total variation. So the first partition is the variation due to treatment, which is actually computed using the TRSS, which is yun, makikita dun sa ANOVA table. And then the other partition is the error sum of squares, okay, or actually computed because we want to have this variation due to randomization. So, ito yon, dito yung nagre-reflect sa, as you can see in the ANOVA table, the ESS. Okay. Now, we start from getting the sum of squares, and then we divide it to the degrees of freedom to get the mean. So from the total, we get now the mean, and then we get the ratio of this, and we get the F. And that's it. You now have your F value. Okay? But again, take note that we cannot use the F, okay, test if the assumptions are not satisfied. So what are those assumptions? Number one, homogeneity variances. We need that. Number two, normality. Number three, independence of experimental errors. So this time, I will illustrate to you on how to check on these assumptions. Okay, I'll start with this homogeneity of error variances. So we have homogeneity of variances. So the variances of the experimental errors of the groups must be the same. So you expect here, if, for example, you have how many applications of, is that sulfur or nitrogen? So you have 3. So you have 3 groups, okay, for group 1 for level 1 or the nitrogen level 30, and then the next group, okay, group 2, and then the next group, group 3. So you expect that we have these different variances from each group, and that should be, this variances should be the same, okay? So we have to test that. So that's our HO. So sigma square 1, so this is the variance under group 1, okay, equal to sigma square 2, this is the variance under group 2, okay, and so on. Okay, so this is a very general hypothesis kasi hanggang T. But in our study, we only have until sigma square 3, sub 3. So in short, we have these error variances which are equal for all the treatments. Versus the HA, at least one. So kahit isang variance lang ang naiba from the rest. So at least one pair of error variance are not equal. Okay. Then we have this test procedure, Levene's test or Bartlett's test. These are common tests. Okay, you can use R or you can use SAS or you can use theta to come up with these values. And then decision rule. Okay, we may use the p-values if we're using a software. So p-value less than alpha, otherwise reject HO if p-value is less than alpha, otherwise fail to reject the HO. Okay, so this is an example on how we check for this assumption. We have this STAR software. I'm not sure if you're familiar with STAR, but this is a free software wherein you can download and then install it for free. Okay, you may go to ERI website. Okay, and then okay, later I will illustrate to you how to do this. Okay, we have this p-value. This is very important. So this will help us decide whether to reject or fail to reject. Now, if this is greater than, what is our set value? 0.05. So if this is greater than 0.05, then we, what? Okay, fail to reject HO. And it's a good news to us because meaning the assumption is satisfied. Okay, so if it's great, if the p-value, okay, is greater than alpha, we fail to reject the HO, okay, and then we can say that the homogeneity of error variances assumption is satisfied, and that's good. Okay. Another assumption that we have to deal is this normality of errors. Okay. Now we have this experimental errors of the different groups must follow a normal distribution. Okay, some popular tests, we have this chi-square, Kolmogorov-Smirnov, and then Wilk-Shapiro. Okay, but yung common dito is Shapiro-Wilk or Wilk-Shapiro. Okay, so HO here stated as the errors follow a normal distribution. HA, the errors do not follow normal distribution. Okay, then we can use the software, the STAR software, to check on this. Okay. This test using Shapiro-Wilk, and then decision rule, reject HO if p-value is less than alpha, otherwise fail to reject the HO. Okay, an example. So since we have different groups, so we have to check normality for each group. Okay, so we have the p-value. Okay, for group 1, we have 0.92. That's greater than, way higher than 0.05. Also 0.99, way higher than 0.89. So good news po dahil we have satisfied this assumption of normality. So at least we can proceed. Okay, after the homogeneity variances, we have this normality of errors. What's next? The independence of errors. So independence of errors are actually, okay, must be part of the design in terms of randomly assigning the treatment. So if you're confident that you have randomly assigned the treatments to the experimental units, then you have satisfied this assumption of independence of errors. Okay. And then, okay, we go back again to the example. Okay, so we have this mu, HO and HA. So I've discussed this already, the test procedure, the F. And then the statistics, we have this ratio. And then the decision rule, you can use the F and the p-value. Okay, if, for example, you don't have the software or you are not, if you want to at least try doing the manual computation, so you have this formula here. So you are provided with this formula, okay? And then for sure, this formula will give the same result with that of the software. Okay, so okay, just to show you now, my correction factor, my total SS, my treatment SS, and the error SS. Okay, okay. Now this is our ANOVA table. So we have this SS. Take note, we computed for 9.4, 2.66, okay, and then 6.74. So these values are found in the next slide to 9.4. Yes, this one. This is the total SS, the TSS, the ESS, and the TRSS. So this one divided by the degrees of freedom, then we have this a mean square, and then we get the ratio, and then we get the F, and then we compare. So how do we compare? So we compare it to the tabulated. So I'm showing here the formula or the function and how to come up with this 4.26. So you can use Excel kung wala po kayong F table. You have this formula I'm showing. And then just press enter. So input this, okay? And then enter, and then you will have this 4.26. And then you can now compare. So 1.78 is less than 4.26. So that means that we fail to reject because we only reject if it's greater than. And sadly, in this case, we have less than. So we fail to reject. And therefore, at alpha 0.05, the mean yield of corn among the different nitrogen levels are the same. Okay? So, parehas lang daw ng result or yung means no different levels. Okay, so if you are a researcher or if you are trying to compare this and if you see na they are just the same, then you just go for the less or the least expensive level. Diba? Okay. Okay, this is an output coming from this R, okay, R software. We have this p-value 0.226. So we can use the p-value to compare, to decide whether to reject. So 0.22 is we compare this to 0.05. Okay, that's greater than 0.05. So we fail again. So consistent. Okay, consistent yung result natin na fail to reject. Using the F and using the P. Okay, so the same daw lang yung means. Okay, so how do we, okay, I'm introducing now the R software because it's free. And then, yun, you can just download this. So you can go to this link or to this website, okay, and then download this too. So this star will not work without this R package 1.2. So you still have to download R, okay, but it's fine because after this, it's easy for you to do the analysis. Now, just to show you on how to use star, okay, using to come up with the layout of this randomization. So they have this feature here. We have design and then completely randomized design. And then you just set your values here. So you have 4 replicates and then the number of field rows. So I want the layout to have 3 rows and then just one for one trial. And then take note also of these levels. You have 3 levels, so you have 3 here. Then okay, then you have this result. So easy. You don't need a calculator or an Excel. No, you just have to use this star and then come up with this layout. And then you have the idea on how to randomize or how to randomly assign your treatment levels to the experimental units. Now another is when we do the CRD, okay, analysis here. So before the analysis, of course, you have to input your data. No? So you start from project, the new project, and then you try to write the name, the project name, and then okay. And then from that, automatic, there is this folder here, CRD, with the name of your project. And then there is this folder for data and another folder for the output. For the data, you just right click and then you can see the import data. And then you just choose anong data na gusto i-analyze and then open. And then you have this. So easy. So you can see the data if you click the data folder here. Okay. Next is, okay, how to do the analysis. Okay, so once you have inputted the data, okay, so you go to analyze, then analysis of variance, given that the assumptions are satisfied here. Okay, so there is this feature also in checking for the assumptions. You can go to this descriptive stat here and then have this normality test. Okay, so this one I'm showing to you is the, given that assumptions are satisfied. So you have this analysis of variance, then the CRD, and then you just click this tab here, and then the tab will show this. You have to move this variable name. So yield, okay, that's your response, and then the treatments, that's actually your TRT based on the data that I have. And click OK, and then automatically you have this ANOVA table. So easy. Okay, but take note again, before doing this, you have to check the assumptions. Okay, now think about this. Knowing that at least one of the treatment levels has a different mean, how do we know which treatment mean differed significantly from the other treatment means? So meanings, how do we know that which level or which group is different from the rest? Okay, so anong level, anong group yon? So the answer is by using pairwise mean comparison or group comparison. So for the pairwise, we expect that we have this, for example, 3 levels, compare A with B, A with C, B with C, and so on. And then for the group comparison, you can compare group A with group B and C together, or group B with group A and C together. So that's under group comparison. Okay, we will not be discussing this because somehow there are lots of procedures under this. Okay. But at least you have the idea that you can proceed to pairwise comparison in case you have a significant result. Now, another thing that you have to think is, in reality, it is very difficult to find experimental units that are homogeneous. I hope you agree with me, right? Especially if you're in the field, no? And then experimental units are markedly heterogeneous with respect to some criteria of classification. So we call them nuisance factors, or yung mga criteria na yon. So example, plot may differ in terms of fertility. Although your intention is to compare just the type of irrigation, okay, and then you apply these types of irrigation to the plots, okay, but then this plot has this inherent condition or this factor, okay, that they have this not the fertility of these plots are not uniform. Okay, so you cannot control that. Okay, another example is that trees may differ in age. For example, you want to compare the different levels of fertilizers applied to trees, but then the responses, or say the harvest or the yield of these trees, okay, may differ or may be affected with the age of the tree, right? So that's another nuisance factor, that age. Another example, soil may differ in terms of pH or acidity. Okay, so when you want to compare the soil maybe in terms of level of the fertilizer, okay, soil can have this another nuisance factor, the pH, that can affect
Ma'am
the
Lara,
yield. Yes.
can I just interrupt? I
Yes.
think the slides are I think stuck because we
Are you
are
sure?
only seeing this pairwise mean comparison.
Oh, really? Maybe I have to refresh. Ano ba?
Can
Wait lang po,
you could stop sharing for a while.
Okay. Siguro napagod na din siya. Okay. It's okay. Okay, so I'll go back to the slides. Okay, I will try again. Oh, it's not, wait.
I
Done.
think it's
So you're until here.
yes.
And then if I move
And then the next
this,
slide. Yeah,
you can see
there.
it. Okay.
Yeah.
Ang dami ko pa namang sinabi. So
Sorry
yun.
po.
Oh, yun. So I hope you understand my point now that there are other factors that's already there in the experiment or in the research that maybe you have to consider those and then you have to control. No?
Mhm,
Okay, so yun. So these are the examples. So do
mhm.
I have to go back to these examples?
Oh, it's okay.
It's
I
okay.
think
You
ito
heard
po
me
yung
naman.
parang mga nuisance factors na
Yeah.
sinasabi ni Ma'am Lara. Kasi in our last webinar, yung term na ginamit po namin is confounding variables.
Yeah.
Yun, parang tawag dito sa mga students in chemistry, ito po yung parang mga anong tawag dito? Yung mga
Conditions.
interferences.
Yeah.
Yun.
Conditions niya naka-affect dun sa response din.
Mm-mm.
Okay.
Yes.
So I'll proceed now.
Yes, ma'am.
Okay. So nag-intro lang, intermission lang tayo ng konti. Okay, another thing that we have to think, okay, this one nga, yung nuisance factor. It's a factor that probably influences the response variable but is not of interest. So how do you consider that? Okay, so we now have this blocking, okay, and also have this another statistical technique that we have to use. Okay, so but we will only, okay, we will just discuss on this RCBD, which is actually under blocking, and then Latin square design, another procedure under blocking, okay, and then this incomplete block design, this is another design, but we will not discuss this since kulang na po tayo ng oras, but at least the basic designs or the structures, design structures are, okay, will be discussed later. So under blocking. Now, for the use of another statistical technique, we have this ANACOVA or analysis of covariance. So what is this? This is just a procedure with the combination of regression analysis and ANOVA. Okay, so that's very interesting actually. But we will just focus again with the RCBD and the Latin square. So now I'll start with the RCBD. Okay, so RCBD or randomized complete block design. Okay, this assumes a single gradient running across the experimental units. So ito yung nuisance factor na kailangan na i-consider natin, that single gradient, or we call it block. Okay, so the blocks or the blocking factor. Blocks are of equal size and each contains all the T treatments. Okay, so imagine that you have one block or a block having all the treatment levels there. So may presence ng lahat ng treatment levels. That's why it's called complete block. Okay? So complete block design. And then the experimental units within block are homogeneous. You expect that in one group or in one block, the conditions, for example, the variety or the type of soil, okay, homogeneous yung lahat. Under homogeneous condition yung experimental units. And then the variability among blocks is taken out of the experimental error. So because our goal is to minimize experimental error, okay, we need to consider a blocking factor so that, okay, yung pagkakaiba among blocks will be, okay, incorporated in that blocking factor na source of variation. Okay, basta the goal is to really minimize the experimental error by, yun nga, having this blocking factor. Okay, just to illustrate, so this is a picture of a single gradient, example, fertility gradient. So as you can see, say siguro the first row, less fertile siya compared dito sa last row. Okay, can you follow? Okay, so yun, nagdi-differ yung level ng fertility across rows. Okay, since if you have the idea nga ganon, so that's the situation of the experiment. So you have to consider blocks here, wherein you have block 1 having the same level of fertility, or for example, block 1 having a less fertile part, and then the block 3 with the most fertile part. So ito yon in the same block. Okay, and take note that block 1 has these 3 treatments, okay, present, and block 2 the same. The 3 treatments are all present, and then the block 3 also has these 3 treatments present. Okay, so now gradient is unidirectional. Okay, this one direction lang. Orient blocks such that they are perpendicular to the direction of the gradient. So if this is the direction of the gradient, so ganito yung blocks mo. And then use long and narrow blocks. So this is just a suggestion, no? okay, to accommodate all the treatments. So we have long and narrow blocks. Okay. Oops. So we now have to consider this. Now, considerations in blocking. First, select source of variability as basis for blocking factor. So you really have the idea kung ano yung possible factor or nuisance factor, no? Okay, in the experiment. So that's your blocking variable. Then select the block shape and orientation. That's why yung kanina we have perpendicular in this shape, long and narrow. And then we have to consider grouping of these experimental units into blocks such that the variability within each block is minimized. Okay, yung discrepancies within the block is minimized. So halos pare-parehas lang yung condition. Okay, while the variability among blocks, okay, are maximized. So talagang nagdi-differ si block 1 sa block 2. For example, yung soil type. Soil type na clay, nagdi-differ talaga siya sa loam and so on. Okay, so we have this application. So usually yung mga applications ko is on this agricultural experiments because basically yung experimental design actually was developed with this from this agricultural experiments. Okay, we can also apply this RCBD, to biological or medical experiments. So think of something, experiments na biological or medical. For example, you want to compare the, say, different dosages of drug, okay? And then, ano yung possible block could be in the experiment that can also affect dun sa mismong effectivity ng treatment. It could be the age, right? So your age can be your blocking factor. Then market research or in business. For example, you want to compare the different brands. You want to compare the different brands, okay? And then, so yung price, siguro yung response variable. And then yung blocks could be the different department stores or different malls, okay? Yon. And then sa engineering, industrial experiments, maybe you want to compare the different temperature, okay, different levels of temperature, and then your block would be the different brands of machine. Okay, so that's it. So those are some applications of using this RCBD. So randomization and layout. So we have this illustration. So let treatments T1, T2, T3, T4 be replicated 4 times respectively. Thus, the total number of experimental units needed is 16. So if you can imagine, we have 4 treatments, and then we have 4 replicates. Okay, so these 4 replicates are actually your 4 blocks. So 1 block, 1 replicate, having these 4 treatments, another block, another 4 treatments, another block, another 4 treatments, another block, another 4 treatments. All in all, we have 16. So that's 4 times 4. Now, we have to group these experimental units into 4 blocks. Okay, so we now do the grouping. Okay, dapat homogeneous, no? Kada block, okay? And then divide each block into T experimental units. Okay, so 1 block, 4 experimental units, since we have 4 treatments. So for each block, randomly, wait, cannot read, have to move. Randomly allocate the treatments into the experimental units at random. Okay, so take note that hindi lang siya bastang direct na ina-applyan ng treatments. You really have to randomly assign these treatments to that block or to the certain block. Okay, so wait. Now we have this data presentation. So if you have this 4 replicates, so we have 1, 2, 3, 4 or 4 blocks, and then 4 treatments, 1, 2, 3, 4. So we have this. So 16 observations. And then we get the total and the mean. And then so that we'll be able to understand this design structure. So we have this example. An experiment was conducted to determine the effectiveness of 4 weight reducing programs. So there are 4 programs. Each program was randomly assigned to any overweight individual of each age bracket, and the weight loss in kilograms after 30 days was then recorded. Okay, so just a counting recall. Treatment here is the weight reducing program, and then the treatment levels hindi pa na-mention, pero it could be level 1, 2, 3, 4, or A, B, C, D. And then experimental units, we have 16, okay, individuals. Then response variable is the weight loss. Okay, so is blocking needed? Yes. Okay, why? Because age can have an effect on the weight loss, right? Okay, so you have blocking factor for age brackets. Okay, now determine whether at least one weight reducing program resulted to a different weight loss mean. So also determine if the blocking is effective. So you have to test two for the treatment, for the program, and for the age bracket or age group. Okay, conduct experiment at 5% level of significance. So now to illustrate, okay, we go back to this randomization. Paano mag-randomly assign ng treatment? So these 4 programs. So okay, this age brackets are already set. So fixed to. Okay, blocks are fixed. So we have 15, 19, 20, 24, 25 to 29, 30 to 34 years old. And then for this first block, we assign, we have this. Okay, ano pa, nag-set muna tayo ng numbers, 1, 2, 3, 4, 5. So ganun lang yung arrangement, ascending order. And then the next step is to generate random numbers. So if we generate these random numbers, okay, take note for block 1, what is the lowest value here? So it's 0.209, so that has rank 1 or rank 1. And then the next is 0.368 that has rank 2, and so on. So ganun din. You have to assign ranks again for the next block. Okay, having this smallest or generated random number, rank 1, and then the rest. Okay, so I hope you understand. You can follow this one. And the next is we now assign the treatment. So take note that the rank 1, okay, of this experimental unit will receive, okay, this treatment A, then 2, B, and then 3, C, and then 4, D. Then the same process in the next block, you can have this 1 as treatment A, 2 as treatment B, then 3 as treatment C, then 4 as treatment D, and so on. So I hope you follow. Okay. Now, okay. So given that we have randomly assigned those treatments or programs to those individuals, overweight individuals, and then, okay, so you apply this program and then you wait for 30 days. Okay, then after 30 days, you measure yung weight niya. So yung weight loss, okay, kasi diet program siya or weight program. Weight reducing program. So yung ABCD natin, so dito nilagay ko lang specific. Okay, we have A, intermittent fasting, B, vegan diet, low carb diet, ultra low fat diet for D. And then we have these results. And then how do we analyze now? Okay, so take note that this our responses here, or the weight loss actually, can be modeled, okay, using this. Okay, so recall before in CRD, we don't have this term, the raw, this one, the third term. We don't have this. We only have mu plus tau I plus epsilon ij. Now, for the RCBD, we have this additional term. Okay, if you're just interested now to model the responses, you have this. Now, Yij is the weight loss or the observed value. The mu is the overall mean. The tau is the effect of the I treatment. And then the rho j is the effect of the block. And then the epsilon ij is experimental error. Okay, so again, we have to check first the assumptions before we proceed now with the test. Okay, so assumptions on this. Last time we have discussed this homogeneity of variances, the normality of errors, and then this independence. No, another or additional assumption that we need to consider is, we need to actually check is the additivity of these treatment effects. Okay. Okay, so this is very important. Okay, you cannot proceed with the CRD or the analysis for the CRD if this assumption is not satisfied. Okay, so what is additivity of effects? So treatments and environmental effects. So yung environmental effects or yung nuisance factor or ito yung blocking factor. So the treatment and the blocks, okay, do not interact. So dapat walang interaction, meaning the effects of treatments across blocks, okay, effects of treatment. So treatment 1 sa block 1, treatment 1 sa block 2, treatment 1 sa block 3, and so on, are uniform. And the effects of blocks, okay, across treatments are also uniform. So in short, walang interaction doon sa dalawa. Walang specific combination ng treatment and block na that has an effect doon sa result. Okay, dapat uniform. And then we can test this using the two-keys test. Okay, so two-keys test for non-additivity. Okay, take note, we also have this HO, the treatment and the block effects are additive or do not interact. And then we have this HA, the treatment and the block effects are non-additive. Then test procedure, two-keys test for non-additivity. And then decision rule, okay, we reject HO if the p-value is less than alpha, otherwise fail to reject HO. So we use the alpha here. Okay, if we are using the software. Okay, so just to show you the result, okay, so using two keys, we have this p-value 0.8. So this is very high. So meaning to say we have satisfied the assumption of additivity. And then if we want to picture, to somehow at least have an idea of the picture of this non-additivity, you have this graph here. Roughly parallel sila. Okay? So this will give you a hint, kahit hindi ka pa mag-test, this will give you a hint that we have this additivity assumption satisfied since parallel lang. Halos same behavior, same flow all throughout, no? All throughout the treatment levels, okay? Per block, same lang yung behavior. Okay, so that's one way. Then another is to test again for this. The formal test is to use the two keys. Okay, homogeneity of error variances, you're already familiar with this. So the same HO, okay, sigma 1 square equal to sigma 2 square and so on. And then the error variances are equal. So that's your HO. HA, at least one pair of error variances are not equal. Then the test procedure, the same, Levin's or Bartlett's. And then the decision rule, we reject HO if the p-value is less than alpha. Otherwise, fail to reject HO. Okay, so this is an example. Okay, we have this Levin's result, test result, the p-value that's greater than alpha for the treatment and even for the block, 0.88. It's still greater than alpha. So therefore, we have satisfied the assumption of what? The homogeneity of error variances. Okay, the next assumption that we have to consider again is the normality. Okay, so you have this HO follows a normal distribution, HA does not follow a normal distribution, and then Wilk-Shapiro or Shapiro-Wilk sa ibang software, then we use the p-value. So assumptions of per group, okay, so we see that the p-values you can see here, 0.8, 0.85, 0.51, 0.36, all of these are greater than alpha, which is 0.05. Therefore, we have satisfied the assumption of normality. Now, the independence of error, that's the last assumption, satisfied, okay, again, using randomization. Okay, so we have the summary here. So far, lahat naman po ay nasatisfy. So we can proceed with the test. Okay, so the test now is this F. Okay, so take note na aside from the muse that we usually use, okay, we can have this fixed effects, no? HO for fixed effects and then HO for the random effects. So, ganun lang din, tau I and then sigma squared lang, yung notations natin. And then the F, again, we go back to F, we have this ratio. And then decide using F or using the p-value. Okay, take note also here, okay, here we are dealing with the comparison among the treatments, right, in terms of means. And then here we are dealing with the comparison among blocks. So we compare blocks. So we have to test the HO, blocking strategy is not effective. HA, blocking strategy is effective. Okay, so we have this. So pag not effective, no differences in the means among the blocks. Okay, so to summarize, okay, we have this hypothesis for the fixed effects and then random effects. Okay, and then we have this test statistic. Nagkaiba lang is yung numerator. The numerator under the treatment is the MSTR. So under the blocks, we have MSR. R is actually replicate or block. Okay, and then the decision rule, you can use the F or the P value. So I hope you can follow. So ganun lang yung pattern. We state the HO, the HA, and then we should know the test, and then we check the assumption and proceed. Okay, then decide, then make a conclusion. Okay, we go back to this example. Okay, so we have this. I am showing you the manual computation. Okay, in case lang you have time to check or to verify na same lang yung results sa software and then yung sa manual computation. Okay, so we have this, okay, ANOVA table here. So take note that there is an added variation. This is the block as the source of variation. Before, for CRD, we only have treatment, error, and total. Now we have this additional variation. Okay, so we have this row. Okay. And then I'm using now the R. Okay, our software to come up with this result. Okay, as you can see, significant, highly significant yung treatment. But for the block, which is the age, okay, it's not significant. Okay. Now, okay, so this is just a quick review. So we have to state our HO here, no differences among the means. HA, at least one diet program has a different mean. And then test statistic, we use the F. Okay, assuming na, ayun nga, nasatisfy yung assumptions. And then decision rule, okay, we have this. And then recall that our p-value using the software, we have 0.004, this one here. So we can now compare this to the alpha, 0.05. Then, since it's less than alpha, we can now reject the HO. Then the conclusion, we have sufficient evidence to say that at least one diet program has a different weight loss mean, or the diet program is effective. Okay? Effective siya kasi, again, ina-reject natin yung HO because of the p-value na less than 0.05. Okay? Now, since, okay, before, in the previous discussion, yung about sa if in case significant yung treatments or yung pag-test ng treatments, if, okay, there is this significant test, or we found out that there is this difference in the means, okay, we can now proceed to pairwise comparison. So for the pairwise comparison, using 2-keys HSD, this is automatic when you use the R commander sa R software. Okay, so you can use this, and then you can check the p-value. So the p-value here for the B and A, so pair B and A has this 0.002, meaning to say this B and A differs in terms of their means, right? Okay, so this diet program A and diet program B differs. And then another pair that differs, ano pa? We have the C and B. Okay, so this B again and the C, and then another is the B and the D. So therefore, in short, we have this diet program B that differs from the rest. I hope you agree with me. We can go back to the raw data. I'm sorry. If we go back, at least we can relate now bakit naging ganon yung result. So balikan natin yung raw data. Okay, B, where is the diet program B? Here. As you can see, siya yung pinakamababa na values for each block. So siya talaga yung naiiba, no? Compared to the rest of the diet programs. Okay, so at least now we understand. Now we can relate the result to the data that we have, or we can even get the mean, the descriptive statistics. Where are we now? Okay, so we're done with this. Okay, we have tested for the treatment means, and then we have tested for this pairwise comparison, and then now for the blocks. Okay. Now the HO, okay, the blocking strategy is not effective, so this is denoted by rho sub j equal to 0 versus the HA, rho sub j not equal to 0, or the blocking strategy is effective. Okay, the test statistic, again, we use this ratio wherein the numerator is now for the block, so MSR. Then decision rule, as usual, we reject HO if the F is greater than the F tab or the p-value is less than alpha. Now, we go back to the ANOVA result. Oh, see that 0.1322. Okay, this one here. The ANOVA result 0.1322 is actually now compared to alpha 0.05. And then, okay, that's greater than 0.05, that value, 0.1. So we cannot reject the HO. Okay, and then our conclusion now, okay, the blocking strategy is not effective. Okay, or there is no sufficient evidence to say that at least one age group has a different mean. Okay, so the blocks are just of equal means. Okay, I'll just show you. I'm just showing you this code. If you're using the R, okay, software. So this is very helpful, especially in getting the result for these two keys. For the for checking for the additivity assumption. Okay. Now we can now compare the efficiency between this RCBD and this CRD. Okay, so to measure the efficiency of RCBD with that of the CRD, we can use this formula. Okay, and if the result using this formula is greater than 100%, then this implies that RCBD is better than the CRD. Okay, wait. Okay, and then if it's less than 100%, then this implies that CRD is better than the RCBD with the same number of replications. Okay, so let's have an example under this. Recall the formula, the ANOVA result that we have in the example. And the formula here, we can plug in the values. Okay, so this 0.7456 is just your mean square for the block. Okay, so that's 0.7456, and then another value 0.3067 is the mean square for the error, for the MSE. So we plug in the values and then we get 128.62%. So lampas siya ng 100%. Therefore, there is this gain in efficiency in using the RCBD over the CRD with the same number of replications. So RCBD is 28.62% more efficient over the CRD with the same number of replications. Okay, now to be equal in terms of efficiency, okay, we need to what? Multiply this value 1.2862 times the number of what's this? Replicates. The blocks here, the 4. Okay? So we have around 6 replicates. Kung mag-conduct tayo ng CRD, okay, we need to have 6 replications. Okay, to have the same efficiency with that of this RCBD. Okay. So what if experimental units exhibit heterogeneity in 2 directions of classifications? So you have to think. In the RCBD, we only consider 1 blocking factor. How about now if we consider 2 blocking factors? Okay, this is the question. Now, the answer is use 2-dimensional blocking factor, or we call it Latin square design. Okay, so do we need a break now?
All right.
Okay.
All right po, sige ma'am. We will have a break first. So, masyadong marami yung na-discuss na ni ma'am. So, ang important factors dun ay makita natin yung step-by-step process. So, ang first step ata na if I'm not mistaken will be yung design of experiments, kung mamimili ka between completely randomized, CRBD or RCD. Tama.
RCBD.
Tapos RCBD. Tapos after that, you will have to test for your assumptions. Tama ba, ma'am? Before you proceed to testing your statistics, you should test your assumptions first. So maraming methods na binigay si ma'am for testing your assumptions. Ika nga check the label muna kung pwede. Kung hindi pwede, di move tayo sa ibang statistics like non-arithmetic if that is more applicable. Tapos after that, you test for yung blocking kasi minsan naman ma'am minsan may mga statistics na hindi naman kailangan ng blocking, di ba? Tama po ba?
Yes.
Pero may mga times na wala. So if yung blocking may blocking kayo na ginawa, so pwede niyo siyang i-test. Pero kung wala naman, pwede ring walang blocking.
You
And
can go back to CRD.
yes,
Kung
tama si ma'am. And then ayun lang siguro, just to summarize yung step-by-step process para makita nila yung overview ng ginagawa ng team for statistics. So maraming paikot-ikot. Pagka hindi pwede to, pwede kang pumunta sa kabila. Pagka hindi pwede tong isa, pwede ka naman pumunta sa ibang types of statistics na pwede mong i-apply sa yung data. So hindi ka mawawalan kumbaga ng treatment.
Yes.
Mayroon yan siya parang mga decision tree. Tama ba yun, ma'am? Decision
Yes.
tree na pag natik mo yung yes, o dito ka, or pag natik mo yung no, dito ka sa kabila.
Yes.
So yan, but break-in po muna natin si ma'am, and we will let Sir Jeff to have some announcements. Sir Jeff?
I would just like to point out, no, in the interest of time po, kasi ito namang ginagawa natin ni Miss Lara, it's to introduce you to all the statistical tools that you can use for designing your experiment. So, yung gaya nga nung sinabi ni Marty at saka ni Miss Lara, meron na itong so you just have to you just have to start with the design of the experiment and then figure out what would actually be the most suitable statistical tool that you can actually use in designing your experiment. And sabi nga, just like any mathematical tool, yung level, yung confidence niyo po sa paggamit ng mga to, it comes with practice, no? Hindi niyo naman kasi talaga ito makukuha na manonood lang kayo ng lecture and then all of a sudden expert na. So you have to apply this. So kaya po kailangan whenever you are working on a research project and there's a need for you to adapt statistics as a tool to design your experiments, you take that chance po. And then again, at the same time, if you get lost, kasi baka mamaya hindi pa talaga kayo ganun ka-confident, just try to reach out to people who are experts in statistics. Kasi I bet, in your local universities, there should be statisticians out there who could help you out. Okay, so ngayon po habang nasa break pa si Ms. Lara, I would just like to give you guys an update on the upcoming events that we have for the remainder of this month and also extending over the months of May and June. So ito po, ilan pa lang to sa mga na-announce na namin. Marami pa po kaming i-anunsyo mga events in the coming months. Actually, marami po kami, halos weekly po. Meron na kaming events until January 2022. So balik-balik lang po kayo sa ating website at saka sa Facebook page para makita po ninyo yung mga updates natin. Okay, so you guys can see my screen, right? All right, so today po we have Miss Lara. It's our training course in basic statistics, and next week po. So doon sa ating mga teachers and students who are actually quite interested in the area of cancer research, molecular biology, and the area of medicine, we have Professor Chad Creighton from the Baylor College of Medicine. So he's actually working for one of the leading research institutions in the US when it comes to medical research. So he'll talk about cancer genome analysis. So ito po, actually, this is more biophysical in nature. Kailangan din ito ng coding. So if there are students and teachers out there who are interested in how you can actually use computer science, specifically applied to cancer research, this is actually one thing that you should watch out for. And then April 30 po, end of this month, is the deadline for submission of entries to Filipino Science Hub Research University's Lions Den competition. So this is a competition where teams of teachers and students are actually invited to submit a research proposal. So essentially come up with a research proposal for a science investigatory project. And what we will do is that we will screen all those entries and we will pick the top 12 finalists from entries from all over the Philippines. And then what happens is that the semifinalists will present their ideas in front of an esteemed panel of judges. These are seasoned Filipino scientists who we call our lions. So kailangan mapabilib ninyo yung mga yan. And then we will be picking 4 winners here. So the top prize, so the winning idea, will receive 10,000 pesos po. And the teachers and students can use it as seed funding for carrying out their research project. And then we will also be picking 3 Lions Choice. So meron kaming tatlong runners-up, each of which will receive, each group will receive about 5,000 pesos in prizes po. And then another perk is the fact that all the finalists who will be chosen will be mentored by Filipino scientists from different STEM areas. So ito po talaga, meron kayong hands-on mentorship from a selected panel of mentors. So we invite you all to participate in this. Again, the deadline is April 30, 2021. And if you have questions about the details, we have all the information on our Facebook page and also on our website. So just look for FilSciHub Research University. There's a menu there right there, and you can actually find the mechanics and guidelines. Okay, and then after that, I believe May 8th, right, Marty and JP? We don't have it here. May 8th, we do have a special topics webinar on computational chemistry. So yung pong parang follow-up po kasi ito dun sa data science training namin and people and also on our webinar about like research topics that students and teachers can actually pursue at the comforts of their home. And so we mentioned computational science or computational chemistry and modeling in that talk. And so nag-request po kayo ng computational chemistry topic, and we're gonna be delivering it. So this particular webinar will be delivered by Professor Ricky Nellis from the University of the Philippines, Diliman. So he's one of the leading experts in the country right now when it comes to computational chemistry and modeling studies. So yun po, May 8th, watch out for that. And then the week after that, May 15th, will be one of the mandatory courses for Filipino Science Hub Research Training Program. So this is our training course number 6, which focuses on how to write a scientific report. So when you're working on a thesis or when you're working on a research project in high school, this is actually a lecture that will give you an idea of the fundamental parts of a research report. So whether magpa-publish kayo sa isang scientific journal or whether magsasubmit kayo ng report as output sa inyong high school teacher, this is actually a training for you. So we'll not only talk about the fundamental parts of a scientific report. What I will also be doing is that I will try to essentially summarize my 15 years of experience of writing different forms of scientific reports, you know, like from project reports being submitted to government laboratories all the way up to a scientific journal and patent writing. So ito, punong-puno po to. Marami itong do's and don'ts that I will be sharing. There will also be some best practices, and we'll try to cover some examples rin, in this training course. And then on June 5 of 2021, we will have another web lecture in organic chemistry. And this time around, Professor Dindiyu of FilSciHub's Head of International Programs and also Professor of Chemistry in Louisiana University, she'll introduce you to the world of alkenes. And also in that particular lecture, I will be introducing high school teachers and students, and even those at the college level who are quite interested in the topic of reaction mechanisms. So dito, tuturuan ko po kayo kung paano magpa-tumbling ng electrons para sa organic reaction. So we invite you all to sign up for these events. These are all for free. Take note of those dates, and I think on June 12 we will also have a green chemistry webinar, and that is to be delivered by Professor Kat Vasquez from I think the University of Santo Tomas. So yun po ang ating mga events over the next couple of months. So we invite you all to participate and sign up in advance. We're looking forward to having you in all these events. Maraming salamat po.
All right. So thank you, Kuya Jeff. Maraming exciting events after this. And of course, this event actually is well received by our audience. We peaked at around 500 watchers at YouTube and 100 here in Zoom. So that's a total of 600. Miss Lara, are we ready for the last part? I think this is the last part, right?
So Miss Lara, Lara's internet unfortunately got disconnected. So she's trying to join back in. Should I?
All right.
leave or
Yeah. So do we still have any announcements, Kuya Jeff or Kuya JP?
I'm trying to fish out Ma'am Lara, actually. Mhm.
Kuya Jeff, I think you're on mute.
Just find a Miss Lara. Just a minute, Miss Lara.
Ayan.
Alright.
Okay.
Yeah. Let's just wait for Miss Lara to
Mhm.
connect. Ayan. Ayan na si ma'am.
Kinabahan ka ba, Miss Lara?
Akala ko wala ng pag-asa.
Ano?
Sabi ko, hala, punong-puno. Anong gagawin ko?
No, it's okay.
Or okay lang po yan.
Ano po, box office hit yung session mo, Miss Lara. Full house tayo.
So, ready na po kayo, Miss Lara, for the last part? Hinga po muna.
Pahingahin muna.
Okay naman ako na.
Pahingahin niyo muna si Miss Lara.
No, I'm good. Okay na po. Pwede na po ako mag-proceed. It's the last experiment. It's the last design structure. So, kahit siguro mga 15 to 30 minutes, pwede na.
Okay po.
Okay. Sige, continue ko na. Baka mawala ulit. Okay, can you try to, na-disable yata ako, sir.
JP, could you make her a host? Thank you.
Ayun. Okay na po. Okay. So, yun. Okay. Okay, thank you for staying. Kahit ako yung nawala. Pero bumalik naman po. Okay, so we're back to this. Again, what we have learned, those design structures, we have this CRD and then RCBD. So another basic design structure that we have to learn is this Latin square design, or we have this LSD. Okay, so can you hear me?
Yes po.
Yes, ma'am.
Okay, you can see me too, and then the slides.
Yes, ma'am.
Yes po.
Okay, sige, I will continue now. Now, just to relate the CRD with LSD. Okay, last time in CRD, we just randomly assigned the treatments to the different experimental units. So we have this illustration here. Okay, and then now for the LSD, it's not just completely randomizing the treatments. So there is this randomization again, but in a systematic way. So how do we do that? Okay. Next, in the next few slides, I will be illustrating on how to systematically randomly assign the treatments to the experimental units. Okay, just to have a picture, ito po yun. Ganito po siya. If you see treatment C here, it should only be seen once in that row and once in that column, right? And then if you see A here, that A must be, once in that, can be seen once in that row and then in that column. Okay, so I hope you follow. So ito yung expect natin kapag we have this LSD as the design structure. Okay, recall again that what if, that I told you, or I asked you about this, what if this nuisance factor, it's not just one factor, so it could be two. So that's why we have to deal with this. We have to apply this Latin square if you have two blocks or two nuisance factors. No, so consider two gradients. So those are the two factors or two blocking factors by using two-dimensional blocking. Okay, of experimental units. Okay, used when experimental units can be grouped according to two sources of variation. Okay, so if you can recall, if we have an ANOVA table, aside from treatment, error, and the total, okay, so the source of variation, we also have block, right? Now for the Latin square, we have additional block. Okay, so medyo nagko-complicate yung ating ANOVA table. So like RCBD, blocks in the LSD must be complete blocks, meaning in one row block, okay, there should be this presence of all treatment levels. Or in one column block, there should be this presence of 4 or complete treatment levels. Kaya complete block pa din siya. used for small number of treatments. Okay, so the disadvantage here is we can only use this if we have small number of treatment levels. Why? Because this will also dictate your number of rows and your number of columns. Okay, so the number of rows and the number of columns and the number of treatments must be the same. Okay, so dapat parehas yung rows, columns, and treatments. An experimental unit should belong to one of the row classifications and to one of the columns. So yun nga, we only see treatment A to that row once lang, and then to that column once lang din. So each treatment must be applied once to each row and once to each column. Okay, so as you can see in the illustration here, kita naman, no, si C, okay, once for row 1 and then for column 1. Okay, application, the same. Ganun pa din sa RCBD. Now, it's just that we consider another blocking factor. So it can be in the agriculture experiment, biological or medical experiments, engineering, or in market research. Then we have this randomization. So the same pattern lang po, yung discussion natin. There's a CRD, RCBD, and Latin square. We have this randomization, then yung ANOVA, and then you have this test of hypothesis. Okay, so obtain a basic T by T Latin square plan. Okay, so you should have this square plan. And then randomize the assignment of row factor. Next is randomize the assignment of the column factor. And then last, this randomization of the assignment of treatment. Okay, so how do we illustrate that? So first, okay, we have this original layout. Okay, so wala pang randomization na involved dyan. So we have this arrangement 1, 2, 3, 4. And then for the rows, 1, 2, 3, 4. And then for the treatments, A, B, C, D, ganun lang. Okay, as you can see. So wala pa po. This is the original layout. And then, what we do next is we get we generate random numbers, okay, to have this arrangement for the rows, for the row factor. So if we generate random numbers, the smallest number here is 0.375. That has so this has this rank 1. And then next, second to the last value is this 0.654. This has rank 2. And then next, rank 3 and 4. So as you can see in the arrangement, we have now 1, 4, tama? 1, then 4. Can you follow? Yung red, para ano, yung red na font, okay, ito yun, red is here. Then 3, then 2. Okay, as your rank 4. So ito yung last sa rank, sa row 4. Okay. I hope, no, you can follow. 1, 4, 3, 2. Okay, so that's for the row factor. Of course, you will not use this when you use the star because they have this way not to randomize. And then for the column, we have this lowest value, the generated value, 0.231, 0.089, that's the lowest value, generated value. So rank 1, okay. So that's column 2. That's why here we have 2. And the next is 2. This is column 4. So we have 2, 4. And then next, the 3, 3. And then the last rank, column 1. So nag-interchange na yung ating columns. And also the rows, no? Na-carry na yung sa rows. Okay, so the next step is the randomization of the treatments. Okay, so from the rows to columns now to the treatments. How? So we generate again random numbers, and then the lowest value of the generated random number is this one. Okay, has rank 1, and then variety M3. So this is your treatment level 3. Okay, we have M3 here. The next one, next to rank 1 is rank 2. So we have M2, M1. So we have M1 here next to M3. And next we have M2 for this, rank 3. And then lastly, we have rank 4 for M4, this one. So if we have 3, 1, 2, 4 for that column, we should also have 3, 1, 2, 4 for that row, for the first row. Can you follow? So this is it. Now, how about the rest of the cells in the table? Where we have this M2 here? Okay, take note that the preceding treatment is M1. Okay, and M1 has rank 2. So what's next to rank 2? It's rank 3, and that is your treatment level 2 or the M2. So I hope it's not confusing. You just follow the ranks. Okay, and then what's next to rank 2, which rank 3 is rank 4. So this is treatment level 4 or the M4. Then next to rank 4 is go back to rank 1. Okay, and then we have this treatment level M3. Okay, so if we have this pattern 2, 4, 3, the same in the second column, we should also have the same pattern for the second row. So 2, 4, 3. Okay, and then how about this? So M4, okay, so 2, 4, and then what's next to M4? We have, okay, M4, it has rank 4. So we now go back to rank 1, which is M3. So that's why next to M4 is M3. And then next is M1. Go after rank 1, we have rank 2, which is M1 here. Okay, I hope you can follow. So this is now the way we randomize or randomly assign the treatments, okay, to the experimental units. Okay, so that's it. So as you can see, M3 can only be seen once in column in this column and in this row. Okay, so that's it. Okay, so we're done with the randomization. So we just take note that if we have 2 treatments, we have this original layout, and if we have 3 treatments, we have this original layout, and if we have these 4 treatments, which actually we tried not to illustrate, we have this layout. And then this is what I told you, this additional, okay, source of variation we have for the first block and for the second block. Okay, before we only have treatment and error. And then for the RCBD, we have 1 row for the block. And then now for the Latin square, we have 2 blocks. So we have 2 rows. Okay, so this is now the structure for our ANOVA table. Okay, so the same pattern nga po. We now state the hypothesis. Okay, first, we can use the mu's or the mu1 equal to mu2, okay, or the tau i's. Okay. So for the HO, there is no difference in the mean response among the treatments. Okay, mean response among the treatments. So you can denote this with this mu1 equal to mu2 equal to mu-t. And then for the HA, at least one of the treatment levels has a different mean response. Okay. And then test procedure again, F test. Okay, assuming that the assumptions are satisfied. And then the F test, we have this formula, we have this ratio. Okay, for the treatment. Okay, take note, the numerator here is for the treatment. Okay, then reject HO if the F computed is greater than the F tabulated, or we can use the p-value. Then, aside from testing for the treatment means, we also have to test for the differences of this or among this row factor. So the block 1. Okay, so you can use this notation. Okay, rho I equal to 0 for your HO. So there is no difference in the mean response among the levels of the first block or the row classification. And then HA, at least one of the levels of the row classification has a different mean response. Okay, at least one, so naiba from the rest. And then and then the test procedure, we have F test. Okay, take note that the numerator now is different from that testing for the means using the treatments. We have this now for the row, okay, row factor. We have MSR. And then for the decision rule, reject HO if the F computed is greater than the F tabulated. Or you can use the p-value. And then, okay, we have for the treatment, our treatment levels, we have for the row, and then now for the column. So we can use gamma. Okay, there is no difference in the mean response among levels. So pag no difference, gamma J is equal to 0. Versus HA, at least one of the levels has a different mean. Okay, so that's gamma J not equal to 0. F, test pa din, then we have this different ratio, yung numerator na iba na. So for the MS column classification. And then we reject HO if the F is greater than the F tabulated, or we can use the p-value. Example, okay, so ito na po yung example. Assuming here that the assumptions are satisfied. So we have this homogeneity variances, normality, and independence of errors, and this additivity, okay? And then for these four applications, okay, they were compared, okay, in a variety of corn. So in terms of yield, 16 plots were positioned 4 by 4 in experimental area. Okay, so my 4 by 4, if you can imagine the experiment, it is believed that soil has texture. Okay, so it could be yung clay, ilang percentage ng clay, okay, or until dun sa anong percentage, yung lesser percentage of clay. Example lang po. And the moisture gradient. So siguro yung first level ay hindi masyadong, wala masyadong moisture. Okay, and then to this level na mas may moisture. So we have this moisture gradient and texture or soil texture gradient. So this can be now your blocks that can affect the yield of this, of the responses, I mean. And then this is used as the basis to incorporate two blocks again in your current experiment. So we have this treatment, row classification, column classification, experimental unit, and the response variable. So I think naintindihan naman siguro kung ano yung treatment, kung ano yung row dito, okay, yung column. Okay, so it depends on the researcher kung ano yung i-assign niya sa row and kung ano yung i-assign niya sa column. So in this example, I assigned the row, the texture or the soil texture gradients as row, okay, row factor, and then the moisture gradient as the column factor. Okay, then these are applied to plots, kaya yung plots yung experimental units. Then the response is the yield. Now, if we have this raw data, okay, as you can see, may blocks, okay, for moisture, okay, kaya column factor or moisture, kaya you can see there columns 1, 2, 3, 4. Then for the texture, we have this row factor, okay, so every row. So 1, 2, 3, 4. Okay, and then we have these treatments here, okay, T1, T2, T3, T4. Parang na-summarize niya lang kung ano yung mga responses. Then we can see the row total, the column total, and then the total for each treatment. Okay, now using star, you can have this output here. As you can see, source of variation is now has significant result. You can see only the row factor, no, that differs, no, in terms of the means. Okay, so if we have this ANOVA table again, okay, you can have the F or the p-value, no, to decide. And then, okay, so we can now use, okay, we can now test now for the differences among the treatments. Okay, correction lang po, ito po ay formulations. Kasi yung example natin ay nitrogen applications. So dito po ay among nitrogen applications, hindi po varieties. Okay, so there is no difference in the mean yield among applications. So that's your HO, no difference. Then HA, at least one of the applications yielded the different mean yield or result. Okay, then you can use again the F kapag na-satisfy yung assumption. And then you have this. Okay, so I showed this to you already. And then the test is statistic. We have 0.6. So this is actually, okay, the value here in the ANOVA table. So 0.6. And then the p-value, if you use the R, you can, the star, you can have this p-value 0.639. And you can compare this to what? To the value of the set level of significance, 0.05. So if 0.6 is greater than 0.05, therefore, okay, there is no enough evidence to say that at least one of the application has a different mean yield. Okay, so wala na iba, no, among these three applications or three treatment levels. Now, next is the test for the row factor. So if we consider row as our yung soil texture gradient, okay, as our row factor, so HO now is no difference among the texture level versus the HA, at least one of that texture level has a different mean. Okay, ganun pa din. Nag-vary lang po sa F kasi yung numerator is for the row. Okay, and then you can go back to the star output and check. Okay, the p-value there is 0.027. Okay, ito po. And so, there is enough evidence to say that at least one of the texture levels has a different mean yield. So, nag-iiba pala yung texture levels. Okay, dun, in terms of the means. And then another is no difference in the yield among moisture levels. So, ito yung column factor natin, yung moisture level. So, that's your HO. Then HA, at least one, okay, has or have a different mean yield. Okay. And then F test, ganun pa din. Yung ratio natin, the numerator has this MSC, okay, for the column factor. And then we go back to the result using star. We have this 0.692 as our p-value, and we compare it again to alpha 0.05. And then there is no sufficient evidence to say that at least one of the moisture levels has a different mean yield. Okay. So it's okay, no? At least in this example, pwede na hindi mag-differ yung treatment levels, pero yung row factor or yung isang block ay mag-differ. So it's okay. Now, to check the efficiency or the relative efficiency of this LSD over the CRD, okay, we have this formula. And then, ganun pa din. If it's greater than 100%, then we can say that LSD is more efficient. And if we have this value less than 100%, then we can say that CRD is more efficient. Okay? And then, okay, so just to continue, given this formula, we have this ANOVA output. So we just plug in the values. So yung mga nasa, what's this? So where is that 0.08? The mean square, okay? The mean square for the column factor, we have this MSC, okay? Yan. And then the MSE, the 0.0016, this one here. And then the MSR, okay, the MS for the row factor, we have 0.0099. Okay, and then after plugging all the values, we can get the result now, which is 193.75%. So that's way higher than 100%. Therefore, mas efficient yung LSD. So the computed relative efficiency is more than 100%. Thus, the added variation of the blocks resulted to gain in precision. Thus, LSD is more efficient, okay, than the CRD by about 2 times, kasi almost 200%. Okay, so now I think we're done. So this is now the summary. First, we had this basic concept, so the terms, the principles, and the design structures. So you were introduced with the different design structures and treatment structures. And then we also had this CRD, then RCBD, then LSD. And then final note, okay, statistics when properly used makes efficient research. However, it is not a remedy for poor conceived or badly executed research. Thus, it is essential that a user of statistics clearly understands the techniques he employs. Then, in case po may consultation po, I would like to introduce this statistical consulting group, which I am also a member. Okay, so sometimes we have this free consultation. We do this nationwide. Okay, last year, so every anniversary, or like every special occasion of Instat, we have this free consultation. But yun nga po, there's a possibility that there will be another free consultation. Or in case po, you can visit this website here para po sa on more details. Opo, yun lang po. I think I'm
Alright.
done.
Yeah. Thank you, Ma'am Lara. Meron atang sasabihin si Kuya Jeff?
Yeah, thank you, Ms. Lara, for the lecture. Pero babe, siguro para medyo makapahinga ka uli ng konti before the Q&A, no? And while
Yes,
we're sorting through the questions sa Zoom tsaka sa YouTube, I would just like to show a couple of slides about our FilSciHub Research University training program. So ito po yung medyo pinasadahan po kanina ni JP. And ito, specifically, we would like to show you all that Yun po aming how many are these, JP? 7 to 8 mandatory.
8. Yep.
8 mandatory training courses. Meron po kaming nakaset na lineup specific to high school students and specific to to college students as well. So ito po, just as an FYI, since medyo magkaiba kasi yung strand ng research track ng high school, hindi naman sila necessarily nagpa-publish po ng thesis. So iba po yung yung set of training courses na nire-require namin yung college, yung high school students and teachers. But then sa college level po, mas may focus kami sa thesis writing. So yun po, magkaiba po siya. Ito po, just check out yung mga naka-upload na po namin ng mga naunang lectures. And one very important aspect po where we're trying to provide you with in all of these lectures is that in addition to teaching you the traditional approaches to each of the steps in a scientific research project. Ang ginagawa po kasi din namin, since all of us in Filipino Science Hub are practicing scientists, we are actually working in research and development. We also have university professors who are not only teaching but are also actively conducting research in the country, or also like in other parts of the world. We are also sharing with you practical tips po. Actually, karamihan din po ng aming mga training courses na una ay actually based on examples, based on real life examples and experiences. So, yun din naman po yung value na makukuha nyo dito sa aming training courses. And ito po, yung po mga nauna namin na training courses, we have covered ideation. This was actually back in September of 2020. So we covered the ideation process and techniques at the high school and at the college level. And ako po, I've been working as a research scientist abroad for about like 12 years now. So yun po, even at the PhD level, nagbibigay din po kami ng tips dyan. Ano ba yung atake kapag mas pakomplikado ang inyong research project? Yung second po namin na training course is on how to research the literature. So, dati po kasi sa Pilipinas, yung training din namin, punta ka sa library, ano ka ng books, or mag-google ka. Pero this time around, binigyan po namin din ng training course on how to actually use modern online resources, kung paano po kayo maghahanap ng relevant literature to your study. Yung third po naman namin is an introduction to experimental design. So ito po, medyo mas broad po yung approach dito. Hindi po to statistics-based. So pininisan po namin yung iba't ibang aspects of designing an experiment or designing of a study. Pero ito pong talk ngayon ni Ms. Lara, this is actually focused on statistics. So so in cases that your project requires that you have statistical design as a critical element in performing your study. So ito na po yung follow-up namin dun sa design of experiment introduction na ginawa namin. And then our fourth lecture po was very important, lalo na sa ating mga estudyante sa high school at college level. So paano ba yung process ng pag-develop ng effective research proposal? So yan po yung mga nauna namin. So kung gusto niyo pong tapusin nyo at makagraduate sa aming FilSciHub Research University training program, balikan nyo lang po ito. Lahat po ito yung nasa YouTube channel namin. And then JP has actually done a great job of setting up a Google Classroom where you can take up all of these courses as well, finish up the entire process. And si JP po kasi ang head ng FilSciHub Research University. Once makagraduate po kayo dyan, you'll become part of the FilSciHub Research University alumni group. At dun po, since we're also bringing in a community of Filipino scientists and international experts from all over the world, yun po mga magiging member po ng aming research university community will have first-hand access kung ano man yung mga materials po na i-deliver namin in the future that could help you develop your not only your passion but also your expertise and comfort level when it comes to conducting research. And then the last slide lang po. So in addition to these training courses, every week we also deliver special topics courses because for us, for you to be able to come up with ideas, in a number of different STEM areas, kailangan familiar din kayo. Ano ba yung mga research areas na pwede kayong maging expert in, lalo na sa mga estudyante. Itong mga special topics courses po na to, we bring in experts from different parts of the world to talk about specific STEM areas that you could specialize in. So for example, we had the talk on nanotechnology. We brought in a renowned Filipina expert when it comes to mycology and taxonomy. Last week, we had Professor Gerard de Mancas who talked about chemometrics. We also had a very successful talk on data science. So data science was delivered by Professor Kevin Season. And this is actually an up-and-coming area in the Philippines na actually even at the high school level, pwede mag-start mag-train ng mga estudyante. John Marty Mateo, our very own, he delivered a special topics training course on different areas of research na pwede ninyo pong i-explore sa inyong mga bahay habang may pandemic pa at hindi pa kayo pwedeng bumalik sa lab. And then, as we said, Professor Chad Creighton next week, cancer genome analysis. So ito po, we're bringing all these special topics to you on a weekly basis. So hindi lang po ito one-off, okay, we're gonna train you on how to practice the scientific method and apply it in research. Papalakahin po namin ang inyong mundo. I-introduce po namin kayo sa iba't ibang areas. Ayun, maraming salamat po.
All right, thank you, Kuya Jeff. So I think we can proceed now with the Q&A. Ma'am Lara, are you there? Ayan, nandiyan na
po.
Okay. Ma'am, I will just give you some questions na parang yung pong medyo super mahalaga na laging natatanong din po sa amin. So the first question that we have from YouTube, actually pinagsama-sama ko na po yung ibang question is, yung how do we determine po the ideal and acceptance sample size in different research design? So example po, survey, quasi-experimental, causal, comparative. And yun, marami pong ganun yung questions. Ano daw po ba yung acceptable number of samples?
There are many cases kasi yan eh. Parang it could be, although may formula for that, di ba? Pero ang kino-consider kasi dyan, kung meron bang, given ba yung population size? Or given, kung may cost ba na naka-apekto doon sa pag-gather ng sample size? So, kung simple random sample ba yung technique, yung survey design natin? Or kung stratified ba? Kasi iba-iba kasi yun eh. So, there's no definite, kumbaga, value or number. Depende yun sa design mismo. Like for example, if we're doing this experimental design, kahit 3 replicates, di ba, for each combination of treatments, or for, di ba, depende yun actually. Pero there are many formula for that. Formulas.
Tama po. So ang gusto lang sabihin ni ma'am, walang masyadong concrete na number na kaya naming ibigay for now, but you can consult your statistician on the parameters kasi namin.
Yes, kung SRS meron, may formula for SRS. Kung STRS meron din. Then kung may cost pa, that's another formula kasi may mga optimizations yan din eh.
Kuya Jeff, yes?
Okay, siguro Ms. Lara, ito nakita ko lang tong question sa YouTube na I forgot the name. Pero ito kasi talaga yung laging tanong sa amin din when we discuss research, no? More particularly execution of experiments. So ang tanong lagi is, yung nakita ko kanina, ano daw po ba ma'am yung minimum size ng minimum number of replicates?
Actually, pwede yung 2.
Okay.
Pwede ring 3. Pero depende yun sa the precision na gusto mo.
Okay.
So kasi the higher the value or the more the number of replicates or experimental units, the higher the precision. So that would help us validate our experiment if we're doing the right experiment.
Okay. So siguro Ms. Lara, so I think I like the point that you made na pwedeng 2, pwedeng 3. But then siguro kailangan aware din lang ang ating mga researchers na kapag limited yung number ng samples nyo, yung confidence nyo doon at yung precision medyo mababa po. So pero siguro I like the fact that you emphasize na pwede namang medyo maliit. Basta alam lang nila kung paano siguro ma'am i-communicate na siguro maliit yung sample size. Ito yung nakuha namin, meron kami at least 2 o 3 replicates. But then again, in the interest of resources, siguro kung kulang yung resources, siguro acceptable po yung 2 or 3. Pero kung kaya namang i-accommodate na mas damihan yung number ng replicates, edi mas maganda.
Yes.
Yes. Okay, tama. May question po dito, Ma'am Lara, parang ito naman po for sabi niya, may ibibigay daw po ba kayong magandang analogy for the differentiation of grouping and blocking? Kasi medyo confused daw po sila kung ano pinagkaiba ng grouping and blocking.
Actually, parehas lang kasi it's about grouping the same or homogeneous experimental units. It's just that sa blocking, nakikita mo sa field, yung sa soil, tama, di ba? Yung grouping yung mismong tao, yung group mo yung mga bata, na same IQ, same university. Pero parehas lang po siya ng concept.
So ito po ay interchangeable, kumbaga. Interchangeable parang words na pwede mong gamitin sa statistics. But it depicts parang one parameter.
Pero another thing is para kasing generally pag sa statistics, so kahit wala kang alam sa experimental design, yung grouping, you compare group 1 with group 2, say male, female. So you expect that yung sa group 1, para sila lalaki o babae, ganon. So yun din, yung grouping din yun. Diba? Then you can compare. Then ganon din sa block. So kung meron kang yung sa soil gradient or sa mountain 1 to mountain 2. So pwede din yung blocks or midland, highland, lowland. Diba?
Okay.
And then yun. Makakompare mo din yun.
Yes, tama.
Yes.
Kaya JP, may sasabihin ka ba?
Wala naman. Sabi ko lang na interchangeable talaga yung mga terms.
Okay. So ito po parang yes or no question lang. Is the response variable synonymous to dependent variable?
I saw that question too. Oh, yes. Yes.
Yes. And
Response.
meron pa dito parang isang yes or no question din. Is the sampling unit a subset of an experimental unit?
Yes. Yes, no lang.
Diba? For
Opo.
clarification lang po ito. Tapos ito medyo specific question. Ma'am, what if the result of FC is less than F tab, yet p-value is less than the alpha? Should I reject the null hypothesis?
Subjective. Kasi yung although we can use the p-value anytime. But there are researches or may mga arguments about that or debate, no? Na you cannot just dictate, you cannot just simply compare that p-value to alpha na 0.05, 0.01. Pwede ka mag-adjust. Okay,
Tama.
depende sa research. For example, medical research, you have to be strict with yung error mo dapat sobrang baba. Kasi pag konting mali dyan sa experiment at medical research yan, maapektuhan. Maraming maapektuhan. So, depende yon. So, for example, sa mga social research, mataas din yung error dyan na kino-consider. You use the p-value, we compare to, minsan nga 0.1, di ba? Pero although we don't really advise that, pero sa mga social research, sa mga economic research, hindi na yan na-avoid kasi magkaiba, heterogeneous talaga yung tao eh. Pag tao yung sinasurvey.
Yeah. So ang ibig sabihin ni Ma'am ay yung p-value can be adjusted depending on the type of research and the heterogeneity of your sample. Pag medical research nga po, 0.001 minsan yung p-value, di ba? Parang ganun po sila ka-strict. Pero sa agricultural research, parang 0.05 kami lagi eh.
Usual. Kami din yung mga examples namin. Pero pwedeng hindi mo yung state. Pwede hindi ka mag-state ng 0.05. Pwede mo sabihin, the p-value is so low or too high.
Oh, okay.
So, kaya minsan sinasabi ng yung mga publications, mga journals na there is sufficient evidence. Hindi nila sinasabi there is at 0.05 or 0.01.
Sufficient evidence lang yung sinasabi nila. Yes. So yung mataas yung confidence level. Ayan po. Ito po meron po mga messages from the Zoom chat box. Sabi nila po, thank you so much to the organizers, to Prof. Lara. You have enlightened us so much with your lecture. Very grateful to you for helping us in our field. And thank you from Josu Mirabite. Thank you for very enlightening lecture. Hope we can also get an access of some of the materials. So kung pwede po i-share daw yung materials. I think, pero nasa YouTube naman po, so pwedeng balik po.
Actually, recorded po ito. Actually, babalikan nyo si Ms. Lara, yung Ms. Lara, i-post nyo kung meron kayong formula doon na hindi nyo na-catch, na-pick up earlier. And then the good thing about that is that ma-replay nyo yung mga sinabi ni Ms. Lara.
Ayan. So siguro last question na hanap lang ako ng ito medyo specific siguro yung iba kasing question dito Ms. Lara is very specific so hindi ko na siguro itatanong baka ito ay mga
Yung may studies sila, may sariling studies.
Oo,
Yeah,
baka,
yeah, I see.
baka kailangan nito ay personal consultation. Oo. So,
Oo.
wala na po akong nakikitang masyadong questions. Kuya Jeff, may nakita ka pa ba or si Kuya JP?
I think that's about it. Kasi yung iba parang masyadong ang specific.
Yeah,
So,
some are very specific to their studies.
Yes.
It's okay. Ganito na lang. Ganito. So, meron kaming consulting group nga. And then you can visit the website. So you have that you have the idea kung how much is the rate. Usually 250 lang yung minimum for 1
Ayun.
hour. And then
So, ano nga po yung website, ma'am? UPLD.
wait lang po. Nandun po sa slides ko pero hindi ko na ma-share. Wait lang. It's here. Sa https instat.uplb.edu.ph extension services. Paano ba to i-show ko na lang? Or
Sige po.
Pakita niyo na lang po.
Yeah, pero yun na yun. Connected na siya sa instat.uplb.ph. Makikita niyo na yun doon.
Okay. Pwedeng i-share ko na lang din po ma'am dun sa confirmation email dun sa certificate.
Yes po. Opo.
So
Okay.
if you want to have one-on-one consultation, ngayon naman po uso na ang e-consultation kahit po sa mga statistician, meron na rin po siguro sina ma'am na e-consultation.
Yes, we do that actually. Kahapon lang, meron akong consulting. Halos everyday.
Ayan, tama. Kasi medyo madali na ngayon ang consultation kasi lahat halos ay nag-work na online.
Then, lang po, meron din kami yun nga, sinasabi kong free consultation kapag may mga special occasions kami. Nag-o-offer kami for free na consultation. Pero yung analysis, another na po yun. Kasi talagang gagawin namin yun. So, medyo may bayad. Pero minimal lang po, i-compare nyo po dun sa mga private institutions. May mga private agencies for this mga statistical analysis. Medyo friendly yung price namin kasi UPLB kami.
And these are UP professors po, UP statisticians. So, I don't think you will ever doubt the quality naman po. So,
At saka
kami po lahat tinuro, yung pong undergrad namin lahat sa stats, doon po sa institute nila natuto.
galing. Sila lahat nagtuturo.
Apo, I can vouch for that. Mahirap po silang magpa-exam ng stat 1.
Marami po nagpa-finals, marami
po dyan. So,
parang ang dati po ang measure ng talino ng mga BS Chem students ay kapag hindi sila na-exempt sa stat 1.
Marami na-exempt naman.
Hindi nga po, parang pag hindi ka po na-exempt, parang hindi ka matalino.
Pero actually, mahirap talaga siya.
Pero mahirap po talaga yun.
Mahirap talaga siya.
Ayan.
Kasi pinag-meetingan namin yan Grabe yung meeting siya, halos buong araw.
Ayan. So, yun po, kung gusto niyo pong mag-keep in touch kay Ma'am Lara or sa mga colleagues niya po, if Miss Lara is not available, you can always email the Institute of Statistics of UPLB, and yun pong trust me, yun pong sa statistical analysis, mahal po talaga kapag sa mga private companies or private firms. Pero siguro po kina Miss Lara, mas friendly nga po dahil public domain po yung
Public service talaga din po.
Ay, ito, may nagtanong lang isa. Ito, why did you use STAR instead of SPSS to analyze the data?
Okay po. First yung libre ang STAR.
Yon.
Number 2, credible ang STAR. I mean, libre na credible. Kasi kilala ko yung nag-develop, yung mga nag-develop. And they are from Instat also.
Yep. And that's also like one very important aspect po. No? We actually had a meeting with Miss Lara about this na since ang atin pong audience ay halo. Meron po tayong high school teachers and students.
Yes.
Meron din tayong college teachers and students. So we're trying to make the content po as friendly to everyone as possible. And yun po mga ibang software, sinabi po ni Miss Lara, for you to be able to acquire it or use it or makakuha ng license, gagastos po kayo ng thousands of pesos. So ay yung STAR po libre siya. And gaya nga po sinabi ni Ms. Lara, it was developed by some of her trusted colleagues is it in Erie po? Yun.
From
Iri,
Instat
Iri.
sila. Then
Yeah.
Iri.
Ayun, at the
Alright.
Institute of Rice, what's Erie? International Rice Research Institute. Naku, nakakahiya. Kain pa naman ako ng kain sa kantin doon.
Sarap ng rice doon, sir.
Alright. So, ayun po, yung STAR po ay available sa Erie website. Actually, yun po yung ginagamit ng maraming agricultural research institute, katulad po ng IPB. Kasi yung STAR, ang ibig sabihin niya ay Statistical Tool for Agricultural Research. Pero hindi lang naman po for agricultural research talaga yung application niya. Yun, nagkataon lang po na i-redevelop ng mga taga-Instat, ng mga graduates ng Instat. Kaya parang ini-highlight nila para mas catchy yung pangalan ng software.
One last thing, Marty. I think there's a challenge here for you. Sabi niya, sana meron pong FilSciHub modules for statistics. Ikaw yung head ng education. Kayo ni Janice. So,
Ano daw?
Yeah.
FilSciHub.
modules for statistics.
Modules for statistics.
We can discuss that. Kasi syempre yung mga materials namin from Instat yon, so we have to, ask permission.
Apo.
Apo.
Susulat na naman kami ni JP. Susulat na naman si JP.
Yeah, I
Or-
hope mapag-usapan po yan. Then,
Ayun.
just to help.
All right, sige po. With that, we will be concluding the Q&A portion. Yung pong evaluation links are already posted in the Zoom chat box and YouTube comment section. So please subscribe to our YouTube channel and like our page in Facebook. And we would like to thank Miss Lara for her time. Valuable time. Ang daming oras ng 3 oras. Siguro kung nag-consultation si ma'am, kumita na siya ng malaki. Pero
Times 500. Joke lang.
binibigay niya ng libre sa atin ni Miss Lara. Grabe, sobrang energetic ng presentation niya. Kuya JP, meron ba tayong ipipresent?
Yeah. I posted the link already for the evaluation. So pakiantabayanan na lang po, and yeah, I think we'll see you next week for another special topic on cancer genome analysis.
All right. So, Kuya Jeff, any last
Ay nako, maraming salamat po Miss Lara. Thanks for your time. Mag-ano po tayo, magde-debrief tayo after nito. I'll send like for very quickly para po makapag-usap-usap ulit tayo. And actually kanina po the live lecture peaked at about 650 live participants, Miss Lara. So halos nakapuno ka ng music museum. That's how it is. So, and typically marami pa pong nanonood dito. At sa ating pong mga kasamahan sa Pilipinas, mga guro at mga mag-aaral, maraming salamat po sa isa na namang Sabado na tumuto kayo sa amin. Ito po, 3 oras na naman tayong mahigit na nagsama-sama, and maraming salamat po kasi yung pong commitment ninyo sa mga ginagawa natin. We're trying to elevate your mastery of all these essential elements of performing research. Kitang-kita po namin yung kagustuhan ninyong matuto. So, lalo po kaming gaganahan. And again, balik-balik lang po kayo sa website namin, sa Facebook page, para nakita po ninyo yung aming mga webinars at saka mga special topics. So, muli po, maraming salamat. Magkita-kita po ulit tayo sa susunod na Sabado. Meron po ulit tayong session. And then, Miss Lara, we're sending a debrief session separately after this. Mag-ingat po lahat. Enjoy your lunchtime. Maraming salamat po.
Leave ako.
Apo. Leave po dito, tapos may bago po tayong session.
Bago po tayong session.
Thank you po
Okay.
sa lahat.
Ingat po kayo lahat. Maraming salamat po. Take care.
Happy lunch po.
Sige po.